Let's try calculating the area of each triangle. We'll store the area of triangle A in a variable called triangle A area, and it will be a double because that's what the find area function returns. To get access to the find area function, we use the dot operator on the triangle A instance. So we'll write triangle A.find area. Now, you might be thinking, why didn't we write triangle.find area? Isn't that what we did when we used POW on the math class with map.pow? And yes, this is where a lot of people get confused. The reason we did triangle A.find area instead of triangle.find area is because in order to find the area of a given triangle, you have to have a triangle instance. You can't calculate the area of a triangle that doesn't exist yet. The implementation of the find area function relies on the attributes of a given triangle. The base might be 8 or 10 or 15. We don't know until the triangle is actually created. Because we have to have a triangle instance already created to use the find area method, we can say find area is an instance method. For map.pow, we did not need to create an instance of map in order to use the pow function. We just accessed the class and used the function we wanted. That's because pow is not an instance method. It is a static method or class method because you do not need an instance of the class in order to use the function. Because of this, instance methods are often referred to as non-static methods, since you have to create an instance in order to use them. You do not need an instance created to use a static method. You can just reference the class. In a previous chapter, we used char@at with a string, and we did need a string already created in order to use it. In our code, we wrote student first name.char@0 and student last name.char@0, where the student first name and the student last name both evaluated to string values. In both of these cases, we used the dot operator on an instance of a string in order to get access to the char@at method. Because we used the dot operator on an instance and not the class name, char@at is an instance method, not a class method. Understanding the difference between instance methods and class methods is very important as you continue to learn Java. Let's get back to our triangle program. We've created 2 triangles, and we are using the dot operator on triangle A to access the find area function so that we can find the area of triangle A. Let's add a breakpoint when we make the find area function call, and then on the first line of the find area implementation. Now, let's run in debug mode. We are about to call the find area method on triangle A. In the variables window, we can see that our triangle A instance is there with its specific attribute values, and the triangle B instance is there with its specific attribute values. We'll hit continue, and now we find ourselves in the find area implementation. For triangle A, the base attribute has the value 8, and the height attribute has the value 15. We use the this keyword to access triangle A's specific base and height values, and use the base and height divided by 2 formula to calculate triangle A's specific area. Hitting continue, and switching over to the console, we can see that triangle A's area is 60. We can calculate triangle B's area as well. Of course, since triangle B has different attribute values for the base and height, we will get a different output for the area. So let's add a double variable called triangle B area and assign it to the value triangle B.find area returns. Then we'll print out triangle B area with system.out.println triangle B area. We'll remove the breakpoint from the triangle A call and move it to the triangle B call, and run this in debug mode. The first time we encounter find area is with the call from triangle A, so that's why we see a base of 8 and a height of 15. If we hit continue, we'll stop right before triangle B calls find area. Hitting continue again, we are back in the find area function, and now we have triangle B's attribute values for the base and height. These are used to calculate the final area, and hitting continue, we'll switch back to the console, and the final area is 3.897. Awesome. We just used our custom-built find area instance method from the triangle class on 2 triangle instances. With the find area call, we've used the dot operator to access a behavior or method from our triangle class. What about attributes? So far, we've only accessed a triangle's instance values using the this keyword inside its class, but we can also access it outside its class. In our main method, we could print out triangle A's sidelen3 with system.out.println triangle A sidelen3. We use the dot operator on triangle A to access its instance variable or attribute variable sidelen3. We could also print out triangle B's base with system.out.println triangle B.base. The rule here is that it's a function if it has parens and an attribute if it does not have parens. Sidelen3 and base are both attributes here, so we do not add any parens. We are accessing a variable, not calling a function. Let's save this and run the program and see what we get in the output. The last two values, 17 is the length of side 3, and 3 is the base of triangle B. Remember, both side length 3 and base are instance variables. Both of these variables hold information about a specific triangle instance. Just like we had static and non-static methods, we have static and non-static variables. Non-static variables are the instance variables. The base of the triangle, the height of the triangle, they do not stay static or the same between triangle instances. The values of base, height, and the rest of our instance variables change depending on the triangle. A static variable is something that will not change per instance. They hold a value for the whole class to use. For example, we might have a static variable that stores how many sides there are to a triangle. This is something that will not change per instance, but rather, if you change it, it should affect every instance. Similar to how we accessed static behavior or static methods, we access a static variable using the class name. Since it does not change from instance to instance and belongs to the class rather than a single instance, a static variable is accessed with the dot operator using the class name. Let's try adding a static variable to our triangle class. Inside the triangle class, we'll add a static variable above our instance variables. This static variable will be an int, and we'll call it num of sides. We'll give it the value 3. Going back to our main class, we can access the static num of sides variable with the class name triangle and the dot operator. We'll want to print it out to the console, so we'll write system.out.println and then use the class name triangle to access the static variable num of sides. Let's run it. And we see 3 in our console. We have 3 sides to a triangle. Now, this representation of a triangle isn't perfect. Right now, static variable, they do not stay static or the same between triangle instances. The values of base triangle, both side length 3 and base are instance variables. Both of these variables hold information about a specific triangle instance. Just like we had static and non-static methods, we have static and non-static variables. Non-static variables are the instance variables. The base of the triangle, the height of the triangle, they do not stay static or the same between triangle instances. The values of base, height, and the rest of our instance variables change depending on the triangle. A static variable is something that will not change per instance. They hold a value for the whole class to use. For example, we might have a static variable that stores how many sides there are to a triangle. This is something that will not change per instance, but rather, if you change it, it should affect every instance. Similar to how we accessed static behavior or static methods, we access a static variable using the class name. Since it does not change from instance to instance and belongs to the class rather than a single instance, a static variable is accessed with the dot operator using the class name. Let's try adding a static variable to our triangle instance. For example, a static variable is something that will not change per instance. They hold a value for the whole class to use. For example, we might have a static variable that stores how many sides there are to a triangle. This is something that will not change per instance, but rather, if you change it, it should affect every instance. Similar to how we accessed static behavior or static methods, we access a static variable using the class name. Since it does not change from instance to instance and belongs to the class rather than a single instance, a static variable is accessed with the dot operator using the class name. Let's try adding a static variable to our triangle class. Inside the triangle class, we'll add a static variable above our instance variables. This static variable will be an int, and we'll call it num of sides. We'll give it the value 3. Going back to our main class, let's try adding a static variable to our triangle class. Inside the triangle class, we'll add a static variable above our instance variables. This static variable will be an int, and we'll call it num of sides. We'll give it the value 3. Going back to our main class, we can access the static num of sides variable with the class name triangle and the dot operator. We'll want to print it out to the console, so we'll write system.out.println and then use the class name triangle to access the static variable num of sides. Let's run it. And we see 3 in our console. We have 3 sides to a triangle. Now, this representation of a triangle isn't perfect. Right now, we assume the values given to the constructor are valid. None of them are 0 or negative, and they together meet the requirements for a triangle. This is something that you can add on later if you want to, but we are keeping this as simple as possible for now. In this chapter, we've introduced a lot of new concepts. So next, we'll take some time to review what we've learned. So what are the big takeaways from this chapter? First, in Java, we can create classes to organize our code. In our previous example, we used a triangle class to organize data related to a triangle, as well as how we can calculate things from triangle data. A class contains attributes and behavior, also called properties and methods. Every class also contains a constructor, which is a specific type of method that allows us to create instances of the class. Ultimately, a class is just a blueprint, and we have to use the constructor in order to create triangles in our code. Some of these attributes are associated with each individual instance, and we call these instance variables. These were the height, base, and side length attributes in our example. These attributes are accessed with the instance itself, and we use the dot operator on the instance to access instance variables. Along with instance variables, each instance has instance functions or non-static methods. Similarly, these are accessed using the instance with the dot operator and parentheses. We also have class variables and class methods. These variables and methods are static, and we access them using the class name with the dot operator. To use static class variables and methods, we do not need to create an instance. We can just use the class name. This new vocabulary can sometimes be overwhelming, but when you are debugging, Google searching, and trying to figure out how to fix your code, these words often come up. Understanding these concepts is a big hurdle in Java, and once you get it, everything starts to make more sense. It's time to test your knowledge of classes and instances with a coding challenge. Be sure to use what you've learned so far about the different parts of a class, what a constructor does, how to create and use an instance, and more. For this challenge, you will represent a college student's profile with a Java class. You can get creative here about what you would like to represent, but the student profile should contain at least a first name, last name, GPA, expected year to graduate, and declared major. If you want to present more attributes for the student profile, you are welcome to. The student profile class should also have at least one behavior in addition to attributes. You can add any behaviors you would like, but one behavior should increment the student's expected year to graduate by 1. Sometimes a student can't get into the right classes in order to graduate on time and must graduate the following year. To accommodate this, we should have a function that increments the student's expected year to graduate. You can model what type of credits the student has or how many credits the student has overall, but that's out of the scope for this challenge. You are welcome to add them if you would like, but they will not be part of the solution. After you've created the student profile class, you should have a constructor that initializes all of the attributes with dynamic values, meaning the values that the constructor is called with will determine the values of the attributes. In your program, you are welcome to add them if you would like, but they will not be part of the solution. After you create has overall, but that's out of the scope for this challenge. You are welcome to add them if you would like, but they will not be part of the solution. After you've created the student profile class, you should have a constructor that initializes all of the attributes with dynamic values. Meaning the values that the constructor is called with will determine the values of the attributes. In your program, you should create 2 student profile instances that represent 2 different students. You should also call the increment expected graduation year function on one of the students and print out their expected graduation. different students. You should also call the increment expected graduation year. Function on one of the students and print out their expected graduation year value to the console. Good luck! Let's represent a student's profile in Java using a class. We'll create a new Java file and call it student profile. In this class, we'll add our attributes. Each attribute or instance variable will have a data type. So we'll start with first name, which will be a string. GPA will be a double, and expected year to graduate will be an int. Next, we'll add our behavior or instance methods. The challenge said to add a function that increments the expected year to graduate instance variable. So we'll write public and then the name of the function, increment expected graduation year. It will take no parameters. And for the return type, we can have it return the new expected year to graduate value or return nothing, returning void. In this case, we'll say void. In the implementation, we'll be setting the value of the instance variable expected year to graduate. To access this instance variable, we can use the keyword this with the dot operator. For the assignment, we want to access the current value of expected year to graduate and add 1. We can do this by writing this.expected year to graduate and then plus 1. And that's our implementation. Moving on to the constructor, we'll write public, the name of the class, student profile, and in the parentheses, we'll add our parameters. Each of these parameters should map back to an attribute. So we'll have one for first name, last name. With the parameters in order, we can set each attribute to the value that their corresponding parameter is holding. To access the attribute, we use the this keyword. Starting with first name, we write this.firstname. Then we'll assign that the value of the parameter first name. Next, we'll do the same for last name. And that's our constructor. Our student profile class is finished. Now, we'll go to our main class and create 2 student profile instances. Then, we'll assign that the value of the parameter first name. Next, we'll do the same for last name. And that's our constructor. Our student profile class is finished. Now, we'll go to our main class and create 2 student profile instances. profiles created, we'll call the increment expected graduation year function on profile 2. Then we'll print out the value of profile 2's expected year to graduate instance variable. Year function. With the 2 profiles created, we'll call the increment expected graduation year function on profile 2. Then we'll print out the value of profile 2's expected year to graduate instance variable. Let's run the program and see what happens. Profile 2 started out with the graduate instance variable. Let's run the program and see what happens. Profile 2 started out with the graduation year of 2021. The assignment instance variable. It will take no parameters. And for the return type, we can have it return the new expected year to graduate value or return nothing, returning void. In this case, we'll say void. In the implementation, we'll be setting the value of the instance variable expected year to graduate. To access this instance variable, we can use the keyword this with the dot operator. For the assignment, we want to access the current value of expected year to graduate and add 1. We can do this by writing this.expected year to graduate and then +1. And that's our implementation. Moving on to the constructor, we'll write public, the name of the class, student profile, and in the parentheses, we'll add our parameters. Each of these parameters should map back to an attribute. So we'll have one for first name, last name. With the parameters in order, we can set each attribute to the value that their corresponding parameter is holding. To access the attribute, we use the this keyword. Starting with first name, we write this.firstname. Then we'll assign that the value of the parameter first name. Next, we'll do the same for last name. And that's our constructor. Our student profile class is finished. Now, we'll go to our main class and create 2 student profile instances. With the 2 profiles created, we'll call the increment expected graduation year function on profile 2. Then, we'll print out the value of profile 2's expected year to graduate instance variable. Let's run the program and see what happens. Profile 2 started out with the graduation year of 2021. We called increment expected graduation year on profile 2. When we printed out Profile 2's expected year to graduate instance variable to the console, we get 2022. This is exactly what we expect. Next, we'll talk about how you can continue your programming journey. Congratulations! You finished the course. From creating your very first Java program to understanding the fundamentals of classes and instances, you've learned a lot. From here, you can use some of your Java foundations to build your own Java programs. Whether it's a word counting program or a card game, practice makes perfect when you're learning a new programming language. If you want to dive deeper into Java, check out Java Essential Training or the Java Code Clinic series here on LinkedIn Learning. If you want to build advanced programs that store more complicated data, check out my course, Programming Foundations Data Structures. Good luck, and until next time.
Since its introduction in the mid-1990s, Java has become one of the world's most popular programming languages. You can can use Java to create all sorts of software, from the applications that manage microprocessors and Internet of Things devices to industrial-strength web-based applications. Java is also one of the most common first programming languages taught in colleges and universities around the world. The language's consistency and internal logic make it a great choice when you're learning how to program for the first time. I created this course with Java 13, which was released in September of 2019. But all of the Java syntax and patterns I'll show you have remained consistent since the release of Java 11, a long-term support or LTS release that will be supported by Oracle for many years in the future. My name is David Gassner, and I'd like to welcome you to this course about the essentials of programming with the most recent versions of Java. Before watching this course on programming with Java, it's important to make sure that you know this is the course for you. Java is one of the most popular programming languages in the world, and it's used to create all kinds of different software. You might be interested in building enterprise-level web applications using architectures called servers, or you might want to program micro devices or Internet of Things devices. And there are many other kinds of applications that you can build with this language. It's also important to know what Java isn't. It isn't JavaScript, that's the interpreted language that's used in web browsers, and it isn't the programming language you should use to try to build iOS apps. Those are mobile apps for iPhones and iPads. For that, you should learn Swift. Java is also not the only choice when it comes to building applications that work with the Java Virtual Machine. You could instead choose Scala, Groovy, or Kotlin. All of these are other languages that also compile to bytecode that runs on the JVM. And importantly, this is not the course for you if you want to build apps for Android. This course focuses on versions of Java starting with Java 11 and later, and uses syntax that wasn't available in Java 8. Android works mostly with Java 8 syntax, but does not support the newer syntax I'm going to show in this course. Also, if you're building new apps for Android, you might choose not to use Java at all. As of 2019, Android is now what Google calls a Kotlin-first platform. That means you'll get more support and find more examples on the web for how to do things the right way using Kotlin in Java. If you need to work on legacy Android apps and still use Java, then definitely learn Java 8, but this is not the course for that. Watch the course on Java 8 Essential Training. And again, if you're creating new apps, definitely go learn Kotlin. Now, if you've decided that Java is the right language for you, you might be wondering, do I have the information I need to get the most out of this course? This course is designed for anyone who wants to develop software with Java, but it does assume that you have a basic understanding of programming vocabulary. So here's a simple test. If you know what these four terms mean, a statement, a variable, a function, and a condition, not just in Java, but in any programming language, then you're ready for this course. Before you learn Java, you might want to watch some other courses. If you find that those terms I mentioned aren't things you understand, you might go to this course called Programming Foundations Fundamentals. And Java is an object-oriented language and depends on understanding of common terms such as inheritance. If you're new to object-oriented programming, you can watch this course that teaches you about that concept and many others. Throughout this course, I'll be using IntelliJ IDEA, one of the most popular integrated development environments for Java developers. I'm specifically using the free edition of IntelliJ, that's IntelliJ IDEA Community Edition. And you can learn a lot more about how to work in this IDE using this course. These courses and many more are available to help you get ready to learn how to program in Java. When the project that became Java started in 1991, the goal was to create a new portable programming language that could run on multiple operating systems without having to recompile or port the code. The original name of the project was Oak, but due to various copyright issues, it became Java. The original tagline for Java was "Write once and learn everywhere," and the original version was released in 1995, nearly a quarter century from after the time of this recording. The early releases of Java came out irregularly. Early on, new versions were released about once a year, but then gaps started appearing. Between Java 1.3 and 1.4, there were 2 years, and another 2 years went by before Java 5 came out, and this is when a new versioning system was introduced. There were differences now between the internal version, which would be 1.5, and the external or marketing version, which became whole numbers, in this case 5.0. Java 5 was the dominant version of Java for many years. There was a less radical release in 2006, that was Java SE6, but then after a gap of 4 years, a major event happened in the life of Java. From the beginning, Java has followed some clearly stated principles. First of all, its goal is to be a simple, object-oriented, and familiar language. Its simplicity lies greatly in its consistency. Once you learn how to do one thing in Java, you can do it the same way everywhere, because it never deviates from its architecture. It's an object-oriented language, so once you understand the principles of encapsulation, inheritance, polymorphism, and abstraction, and how those are implemented in Java, you'll have a much better sense of how to build build your applications. And for developers who work with C-style languages, such as C, C++, C#, and JavaScript, the syntax of Java is very familiar. Java was created to be robust and secure. Its robustness lies greatly in its object-oriented architecture, because you're designing everything as an object. Everything has methods or functions, and fields that store data and are exposed as properties. And you create applications by combining classes together. This lets you create your code in small chunks, and it makes it easy to debug and maintain your applications over time. Java was created to be... When the project... many years. There was a less radical release in 2006 that was Java SE6. But then after a gap of 4 years, a major event happened in the life of Java. Oracle purchased Sun Microsystems and took over the stewardship of the Java language and the default Java runtime, the Java Virtual Machine. About a year later, Java SE7 came out with some major language improvements. And then in 2014, Java 8 was released. And this version introduced newer, more modern syntax, such as lambda expressions and method references, and a new date-time API. Java SE8 is incredibly important because as of early 2019, this version was still the most popular among Java developers and among organizations that publish applications built with Java. There have been many other versions since then. In 2017, Java SE9 was introduced, and this brought in the JShell environment, the shell environment where you can test out simple Java commands without having to create a whole class or application, and other improvements. Java SE9 was also the dividing line between the old licensing model for Java and the newer one, and it was also the beginning of a new release cadence. Oracle introduced the concept of long-term support versions, and Oracle's plan going forward is that every 3 years they'll release a new long-term support version. This version will maintain support for 5 years, and then there will be extended support available for another 3 years, for a total of 8 years from release. The first long-term support version was Java 11. Then there will be a new rapid release version every 6 months. So Java 12 and Java 13 were rapid release versions, and these versions do not get long-term support. So what's happened since this new versioning system was implemented? Java 10 was a non-LTS version, but it introduced a major new language element, type inference, the ability to declare variables without having to declare the variable type twice. There was a new garbage collector interface and other functionality that was restricted to the JVM that is not exposed in the language itself. Java SE11, the long-term support release, added a new HTTP client and something called dynamic class file constants, which as a beginning Java developer you won't have to worry about. Nashorn, a JavaScript library, was deprecated. And then Java 12 introduced some new functionality and switch expressions, which was still in preview, not ready for production. And Java 13, the version I'm using, introduced many improvements in the Java Virtual Machine and the garbage collector. Even more new functionality was introduced in switch expressions, but that's still in preview, and support for literal text blocks is also in preview. So one of the patterns that you see in these non-LTS releases is that there's a lot of work going on in the Java Virtual Machine and the garbage collectors that's not exposed in the primary language interfaces. Those changes to the language itself come along less frequently. So regardless of whether you're working in Java 11, 12, or 13, you'll be able to follow along with this course. From the beginning, Java has followed some clearly stated principles. First of all, its goal is to be a simple, object-oriented, and familiar language. Its simplicity lies greatly in its consistency. Once you learn how to do one thing in Java, you can do it the same way everywhere, because it never deviates from its architecture. It's an object-oriented language, so once you understand the principles of encapsulation, inheritance, polymorphism, and abstraction, and how those are implemented in Java, you'll have a much better sense of how to build your applications. And for developers who work with C-style languages, such as C, C++, C#, and JavaScript, the syntax of Java is very familiar. Java was created to be robust and secure. Its robustness lies greatly in its object-oriented architecture, because you're designing everything as an object. Everything has methods or functions, and fields that store data and are exposed as properties. And you create applications by combining classes together. This lets you create your code in small chunks, and it makes it easy to debug and maintain your applications over time. Java was created to be portable, so that you can compile it once and then run your application on multiple operating systems and processors. It was designed to be high performance. The original versions of the Java Virtual Machine weren't as fast as C++ built applications, but over the years it's been improved enormously, and today Java applications run just as fast, or sometimes even faster, than applications built in native languages. And finally, Java was created as an interpreted language. It supports multi-threading, and it's dynamic. Interpreted means that the application is compiled to a format that's interpreted at runtime, rather than being run directly as machine code, and that's what makes the applications portable. It supports multi-threading, and it's easy to build applications that do more than one thing at the same time. Let's talk about Java runtime architecture. Again, it's an interpreted language, and that's because when you write Java and then compile it, you're creating bytecode instead of machine language. That bytecode can be loaded onto any operating system that has a Java Virtual Machine. You start off with the operating system itself, which could be Windows, Mac OS, Linux, or any other operating system for which there's a JVM. Then you have the Java Virtual Machine, and you have a choice between those that are distributed by Oracle and others from other vendors. On top of that, you have the core runtime and other libraries, and then finally your own application bytecode, which you compile from your Java code. If you compare Java to C++, you'll see many similarities in syntax, but the underlying architecture is very different. C++ compiles to native machine language, so if you want to run on more than one platform, you have to port the code. In Java, it's write once, run everywhere. C++ supports explicit memory management and multiple inheritance. For greater simplicity and reduction in bugs, Java has managed memory access and is limited to single inheritance. That is, any Java class can only have one direct superclass. If you compare Java to JavaScript, again, we'll see many differences. JavaScript is a pure interpreted language. There is no intermediate format such as Java's bytecode. And Java is a more purely object-oriented language. It uses class-based inheritance. There are a number of different editions of Java. When you're working with the language and the basic JVM, you're using Java Platform Standard Edition or just Java SE. There's also Java Enterprise Edition or Java EE, and this isn't a single software package so much as a recommendation for how to build web applications that are really powerful and robust. Oracle no longer manages Java EE. In 2018, they donated it to Apache, and it's been renamed Apache Jakarta EE. Java ME or Micro Edition is a subset of Java SE. and it's a set of classes and libraries specifically designed for use in microcontrollers, sensors, and mobile devices. Java ME is a very popular framework for use on telephone SIM cards. And there's Java FX, a desktop application framework that used to be bundled with the JDK, but now is available for separate download. The Java Runtime Environment, or JRE, includes the Java Virtual Machine. In the past, when you installed the JDK, the development kit, you automatically have the JRE as well. Now that's a separate download and installation. There are versions of the Java Runtime Environment for all of the supported platforms on which the JDK runs. And it's designed to run all of your Java applications regardless of the framework. So you can run desktop, browser, and server-based applications with the same JVM. If you use the JVM to run desktop or other applications, you should always update it regularly to make sure that you're keeping up with security and maintenance releases. If you're using Java to build apps for mobile devices such as Android phones, you won't be working directly with the JVM at all. Those devices have their own unique runtimes and their own compilation models. The Java Development Kit, or JDK, is available from multiple sources. There's a commercial release available from Oracle, and there are open source distributions available from many other organizations. Regardless of where you get it from, the JDK includes all the tools you need to compile and package your applications. The Java command, which is the runtime, Java C, the compiler, Java Doc, a tool for building documentation, and jar to build zip files that encapsulate complete applications. You should pay attention to licensing when you start using Java. If you want to use Oracle's distribution, make sure you check the licensing requirements. There are restrictions, and it isn't always free. You can instead use an open source distribution of the JDK. In this course, I'll be using a release from OpenJDK, and it's available at this website, but you can also choose free distributions from all of these other vendors. Regardless of which version you use, you'll be using the same basic code to build and compile your applications, and you may decide to use the open source distributions if you don't want the license fees, and you also don't need support from Oracle. Java is a C-style language. That means it shares syntax with C, C++, and other similar languages, but it has its own unique set of rules. First of all Java code is defined in classes. A class is defined in a source code file with the .java file extension. In order to turn that file into bytecode, you use the Java C command, that's the compiler. And then the bytecode can be run on top of the Java virtual machine. You start the virtual machine with the Java command. Here's what a simple class looks like. The first line is called the package declaration. This indicates where the file is stored in terms of the directory structure of the application, but it's also a tool for organizing your code. Next is the class declaration. There might be other lines between the package and the class depending on the needs of your code. The class declaration can start with an access modifier such as public, private, or protected, but then must have the class keyword. The name of the class comes next, followed by a code block. Everything within the code block is said to be a member of the class. This is called a method. In non-object-oriented languages, you might refer to this as a function. It's a way of encapsulating code that you can run. In this example, I'm starting with the keyword public, that's the access modifier. Static, which means you don't need to create an instance of the main class in order to run this method. Void, which means that the class doesn't return anything, and then the name of the method. Within the parentheses, you define parameters. These parameters are designed to receive data as the method is called. The main method is defined strictly in command-line applications as the method that's executed automatically when you start up the class, and it always receives an array of string values. Finally, you have your executable code. This main method only has one line of code, but can actually have as many as you want. So this is a simple but well-formed class that will run successfully on the Java virtual machine. You can also test your Java code in JShell, a command you can run from terminal on Mac or from a command window on other operating systems. JShell was introduced with Java 9, and it lets you just test your code before you take that code and put it into a fully formed class. In JShell, you don't need a complete class. You can just execute one line of code at a time, and then you can take that code that you've tested and save it out to a file so you can convert it to production code. In Java, everything is case-sensitive. So your identifiers, such as variable, method, and class names, all need to be unique in their particular scopes. Because of this case sensitivity, the following are different identifiers from the Java point of view. They all say first name, but the first one is lowercase, the second one uses camel case, and the third is all uppercase. These are each seen as unique. Java in general is not sensitive to white space. That is to say, extra white space doesn't affect how your code is interpreted or compiled. And in fact, if you put in extra spaces, tabs, or line feeds, those will be collapsed by the compiler. Let's say you have 5 line feeds. From a compilation point of view, that's the same as 1 line feed. In order for this to work, all statements in Java must end with a semicolon character. So for example, this is a bit of code that asks hello from Java to the console. And because it's a single statement, it ends with that semicolon character. If you're working on a full-blown class and you forget the semicolon, it'll cause a compilation error. If you run this same command, though, in JShell, it'll work fine without the semicolon, because semicolons aren't really needed in JShell, or to put it more accurately, they're added automatically for you in the background. There are some very strong conventions that are used by all Java developers, and you should follow these conventions. First of all, there's an absolute requirement that all identifiers must start with. You also can't use keywords as identifiers. You can find a comprehensive list of Java keywords up through Java 8 at this webpage, and then you can look at the documentation for more recent versions of Java to find out what keywords have been added since then. There's some very strong conventions for creating your identifiers. Class names always start with an uppercase character, but then use mixed case for the rest of the class name. Methods and variables always have names that start with a lowercase character. So when you look at an identifier, you can distinguish between a class name and, say, a method name or a variable name. Constants are an interesting situation with Java. There isn't really any such thing as a pure constant in Java. There is the keyword such as const. Instead, in order to define a value that never changes, you start with the keywords public, static, and final, and then the data type, string in this case, and then the identifier. Constant identifiers are always spelled in all uppercase. Now, all of these are just conventions. You could do it differently if you wanted to, but it's a great idea to follow the conventions that have been established and are followed broadly within the Java development community. Finally, I mentioned code blocks. A code block is defined by a pair of braces. This is a way of organizing your code, but it's also a way of restricting visibility of variables. When you declare a variable within a code block, it's only visible and useful within that code block, and it expires and is eligible for garbage collection once the code block is complete. You'll see code blocks used extensively with method implementations. Every method has a code block, and the code within the block is the executable code for that method. And loops usually use code blocks as well. So whatever code is within the block associated with a loop will get executed as many times as necessary to satisfy the requirements of the loop. So those are the basics of Java syntax. And for the rest of this course, you'll see how this is used throughout the language. of Java's greatest features is its automatic memory management. Unlike languages like C, C++, Pascal, and others, Java automatically allocates and deallocates memory as needed as your code is running. It decides where data is stored in memory. For example, in general, local variables and function calls are stored in stack memory, whereas object and memory variables are stored in the heap. But this can differ depending on which version of Java you're using and how the Java virtual machine is configured. In general, though, objects are retained in memory as long as they have valid references. When you create a variable and you assign it an identifier, that is a variable name, that's an anchor that keeps the object in memory. When you release that variable, either because its scope is finished executing, or because you explicitly set that variable to a value of null, that means you dereference the variable. That object then becomes eligible for garbage collection. The garbage collector is a background process. It's in charge of allocating and deallocating the memory. It can destroy objects that have been completely dereferenced, but it doesn't have to. The logic of garbage collection is completely up to the garbage collector process. You can tune it, but it'll happen on its own, and it's completely managed in the virtual machine. You as the developer do not have tools to force garbage collection. Garbage collection is an automatic process. The virtual machine that's delivered by Oracle supports multiple garbage collector implementations. Now, understanding and deciding explicitly what garbage collector you're going to use is something you need to learn after you've mastered a bit of the language. When you're first learning the language, I highly recommend let Java handle it. Just use whatever is the default. And the choices of the garbage collector process are made by the virtual machine depending on what system hardware you're running. You can learn more about available garbage collectors and how to configure Java for them at the website listed here. But here are some important tips for managing memory. In Java, each object takes up memory. In order to keep the amount of memory you're using as minimal as possible, minimize the number of objects you create. If you have a choice between creating multiple objects or creating a single object and reusing it, do the latter. There are some system methods you can call in your code that will tell you how your memory is doing, and they're listed here. There's a class named runtime, and it has a method called max memory, and another one called total memory. These can be used to benchmark your application internally, but you'll also find a good integrated development environment such as IntelliJ IDEA that will let you monitor your application at runtime and tell you how it's dealing with memory usage. In order to program in Java, you need to use the text editor. You can choose from a range starting with very simple text editors and going all the way up to full-blown integrated development environments. In the early days of Java, a developer might simply use VI or some other very low-level editor to create text files and then compile their code from the command line. But today, there are many powerful and free IDEs available that can really help you speed up your programming, and most of them work on all the major operating systems that you might be using. Here are some simple text editors that have support for Java to some extent. On Windows, you might choose TextPad or JCreator. Now, these were designed to integrate with Java in much older versions. They haven't been kept up to speed, though, with the most recent versions of Java, and so in general, I don't recommend using those. For Mac OS, you might choose BBEdit, a commercial product, or a version of that product that has fewer features but is completely free, called TextWriter. As with TextPad and JCreator, you'll get colored code on your screen. You might get a little bit of code completion, but you won't have anywhere near the support that you would with a real IDE. You might also choose Visual Studio Code. Visual Studio Code has become a very popular option for developers to use JavaScript, Go, Python, and other open source languages. There is support for Java in Visual Studio Code using the Java plugin, and you'll be able to get some IDE-like behavior from it, but again, nothing like you'll see from the real production IDEs. If your goal is to learn Java, you might choose one of these educational tools. BlueJ has graphical tools that let you visualize relationships between super and subclasses. And when you download BlueJ, you don't need to worry about installing the JDK separately because it bundles the JDKs that you need. Dr. Java is also available. It lets you just start coding similar to what you might do in JShell. It does, however, require an older version of the Java runtime. And unlike BlueJ, it doesn't bundle the runtime with it. Both BlueJ and Dr. Java are completely free. Now, when you get into building real Java applications, you really want to choose a real IDE. There are three major IDEs that are used broadly today. Which you choose might be driven by an organization that you're working with, but if you're working independently, you get to choose your own. You might select NetBeans. This was originally created by Sun Microsystems and then inherited by Oracle, and then a couple of years ago was donated to Apache, and it's now an Apache open source project. It has great tools for working with Jakarta EE, formerly Java EE development, and it also has plugins for other languages. Some of the distributions of NetBeans even include a bundled server, so if you're working on industrial strength Java EE web applications, you can have the server already available within the IDE. Another choice might be Eclipse, with a JDT or Java Development Tools plugin. Eclipse is an open source project and always completely free, and the JDT plugin is also free. There are actually a variety of different distributions that you can choose from, depending on what kind of Java applications you're going to build. If you're building the simple command line applications, you'll use JDT probably, but there are other distributions that are specifically designed for web or desktop development. And finally, we come to my personal choice, IntelliJ IDEA. IntelliJ IDEA is the most popular IDE for Java development today, and there are two major editions. There's a free community edition and a paid ultimate edition. As with Eclipse, there are many different plugins available to support many languages. The most recent versions of IntelliJ IDEA come with automatic built-in support for Kotlin, for example. And for those who develop Android apps, it's important to know that IntelliJ IDEA Community Edition is the foundation on which Android Studio is built. You can download the free community edition of IntelliJ IDEA from this URL. And if you're following along with this course, I'll show you later how you can download and configure IntelliJ IDEA so you can follow along with my examples. Microsoft Windows, there are a couple of places where you can get a distribution of the Java development kit. You could get it from Oracle at this webpage at technetwork/Java. From there, you would go to Java SE, and you would choose the most recent version of Java as of the time you're watching the course. I'll be recording again on Java SE 13. Now, you could use this version, but it's important to note that starting with Java 11, Oracle changed its licensing terms, so that Java is not completely free, depending on how you use it. If you want to just do some testing and development, it's probably fine. But if you want to make absolutely sure that you're using a legal version of Java, you should use a release from OpenJDK. You can find it at this webpage at jdk.java.net. From there, go to the version you're interested in. Again, I'm using Java 13. If you want an older version, you can switch the number, and you would see a message about where to find it. In this case, Java 12 has been archived, so you can go to the archive page. Or if you were to put in 14 at this point, you would get to an early access deal. So I'm going to be using version 13. To install the Java Development Kit on macOS, you need to download the appropriate archive file, extract it, and then copy the files to the appropriate location. There are a couple of ways to get the files. First, find out whether you already have Java installed on your computer. Go to a terminal window and type java-version. If you have Java installed, you'll see output that indicates which version. But if you don't, you'll see this dialog pop up. And from here, you can click the More Info button. That'll take you to Oracle's Downloads page. This is where you get the Oracle distribution of Java SE, also known sometimes as Oracle JDK. Beware though, the license for Oracle JDK is restricted. You can use this distribution for development and testing, but as soon as you get into production, you might have to pay license fees. That's for you and your organization to explore. You can download the free IntelliJ IDEA Community Edition from this webpage. There are versions for Windows, Mac OS, and Linux, and your operating system should be selected automatically. If it isn't, though, just select it. Then click the download button on your computer, and that will start an automatic download. If you're working on Mac OS as I am, you'll get a DMG file. After the download is completed, double-click on the DMG, that'll open it up, and then you can drag IntelliJ IDEA into your applications directory. If you have an older version of IntelliJ IDEA on your system, you can rename it before you drag it to a new version. If you're working on Microsoft Windows, you'll get an executable, an installation program. Run the install and accept all the default options. If prompted to delete older versions, do so. Again, you only have one copy on your computer. Then, whether you've installed on Mac OS or on Windows or on Linux, you'll be ready to start using IntelliJ IDEA for the first time. Now, I've already installed the product on my computer, and I'll start it up using Spotlight on Mac. If you're working on Windows, go to the Start menu, type IDEA, and you should find it there too, and start up the product for the first time. This initial dialog will ask you whether you want to import existing settings. If you have an older version of IntelliJ IDEA installed, you might be prompted to import those settings. I'm not going to import the settings because I want to show what happens when you start from scratch. This dialog asks you what kind of interface you want. I'm going to choose the light interface. That's consistent with older versions of the product, and then I'm going to skip all the remaining settings and accept the defaults. On this screen, I'm going to configure my Java development kit. I'll go to the menu and select Configure, and then Structure for New Projects. I'll click New to create a new SDK definition. I'll select JDK, and then I'll make sure that I've navigated to the correct version of the product. If you're working on Mac, you're looking for JDK13.jdk under the library/Java directory, and you want to choose Content and then Home. If you're working on Windows, go to the Program Files directory, then to Java, and then choose JDK13. There aren't any subdirectories under that on Windows. Click Open or OK. If you see this message that there are experimental features available, click Accept, and now you've created your SDK definition. If you see this numeric value, that means you might have duplicates. I'll click Edit, and then I'll see that on my computer I ended up with two versions. I'll click one of them, and verify that I'm looking at the correct directory. Again, this is the path on Mac OS, not on Windows. And I'll click OK. And then each time I create a brand new project, that's the SDK that I'll be using. Java Development Kit 13 on my computer, or a more recent version if you're working through the course with something later than Java 13. The JShell command was added in Java 9. JShell lets you enter simple Java statements without having to create a whole application. You can use it to test simple code before you add it to a Java class. You can run JShell from anywhere on your file system as long as you've added the appropriate directory to your system path. On Mac, this is done automatically for you. So if you have JDK 9 or later installed, you should be able to go to Terminal and type JShell, and you should see the JShell environment pop up. To exit JShell, type /exit, and then you can exit your terminal window. If you're working on Windows, make sure that you've added the Java development directory's bin subdirectory to your system path, and then you should be able to do exactly the same thing in a command prompt or from PowerShell. Now, I prefer to run JShell from within IntelliJ IDEA using a terminal window, but to do that, you have to have created a project. So let's create a new project. I'll choose Create New Project. In the category list over here, I'll choose Java. I'll make sure that I've selected Project SDK 13, and I'll click Next. I'll choose Create Project for Template and select the only option in the command line app. Click Next again. Then I'll set the project name to Hello World. You don't have to put any spaces in it. And I'll click Finish. And that creates a very simple IntelliJ IDEA project. I'll close this typical day window. And then down here at the bottom of the screen, I'll click on Terminal. Now, that's a pretty small font, so I'm going to configure my preferences. On Mac, I go to the IntelliJ IDEA menu and select Preferences, and on Windows, you would select File and then Settings. From here, I'll click on Editor. I'll open that section and choose Font, and I'll set my font size to 16, and whatever is the default font should be fine. And that should be a little bit more readable. So now down here in the terminal window, once again, I'll type JShell, and that opens up the JShell environment. I'll double-click this bar to expand this to full screen, and now I can start executing commands. I'll create a string variable named S1, and I'll give it a value of Hello World. In JShell, you can include the semicolon if you want to, but it isn't necessary. That creates the variable, and then I can output the value of that variable simply by typing its name. I can create an integer value. In Java 10 or later, you can use type inference. That means you start with the keyword var, then add the identifier and assign a value. And the data type of the variable will be determined by the value you assign. That's the integer. I'll do the same thing with I2. Once again, I'll say var and then the identifier. I'll give a value of 10, and then I'll create a result. Var result equals I1 plus I2. And this time I won't include the semicolon, and it still works. And as before, I can type the name of any existing variable and see the result. JShell supports a number of valuable commands. They all start with a /, and /list gives you a listing of your current code. /save means save this session to disk. So I might say /save mycommands.java, and that creates a text file on your system with that name. You can also load the file with /open. I'll say /open mycommands.java. I can say /reset, and that resets the state. And then I'll press the up cursor a few times and reopen the commands. And once again, list the commands, and there we are. To get some assistance, you can type /help, and to exit JShell, type /exit. And then from there, you can close the terminal window by simply typing the word exit, and you'll be back to your code. So that's a quick introduction to JShell, and I'll be using it a lot in the next few lessons. When you compile Java code, you're creating bytecode files. These files have a file extension of .class. So your primary code file would be main.java as shown up here in the tab, and that will result in a file called main.class. You can compile your application either from the command line or from within IntelliJ. I highly recommend using IntelliJ IDEA for the most part, but it's worth going through one exercise from the command line so you can see clearly what's happening. Notice first of all that my main.java file is in a subdirectory structure called com.company. It looks like a package right here, but I'm going to go to the settings in the project window, and I'll deselect compact middle packages. And that opens up the tree so you can clearly see where the file is stored. Now I'll go to terminal. In terminal, I'll start off at the root directory of my project. And if I type ls on Mac or Linux or dir on Windows, I'll see the contents of that directory. I'll navigate to the source directory because that's where my code is. And once again, I'll type ls, and I see the com subdirectory. Now, regardless of how deeply nested your Java files are, you always want to compile from the source directory when you're working from the command line. And here's how you compile. I'll type javac, and then I'll address the file using the directory structure. com/company/main.java. If you're working on Mac or Linux, use forward slashes, and if you're working on Windows, use backslashes. Press enter, and you won't see any response on the command line itself. But when you go back to the project window, it should refresh automatically, and you should see the new file main.class shown there. Now to run the file, use this syntax. Back in terminal, I'll type Java, that's the virtual machine, and this time I'll use package syntax, not directory syntax, with com.company.main. When you're addressing the class file, don't include the .class extension. Nothing happens. So now I'll go back to my code and I'll add a bit of output. Within the main method, I'll type sout. That's a template that expands when you press enter or return, or the tab key, to system.out.println, and that's how you output something to the console. I'll output the string in double quotes, hello from Java. I'll come back to terminal, I'll recompile, and I'll run the code again, and this time I see hello from Java. Now, the compilation process when you're working in IntelliJ IDEA is a lot easier. At any point, you can go up to the menu and choose build, and then select build project. And that will create an out directory. In the out directory, you'll see production, then the name of the project, and once again, your directory structure. And there's your main.class file. When you're working with IntelliJ IDEA, that's the version of bytecode files that you'll use to package and deploy your applications. So, simple Java files are just text files, .class files are bytecode files. You're in charge of making the text file, and the Java compiler creates the class files for you. When you run a Java command line application, you can pass in values. You have to declare those values within a function or a method, as I've done here. In fact, the main method, which is executed automatically when you start up a command line application, must have one and only one parameter, and it must be an array of strings. In IntelliJ IDEA, the automatic name is args, but the name can really be anything you want. Now, I'm not receiving anything yet, but I might, so I'm going to add a little bit of code here. I'll change this code to look like this. I'll add a comma space at the end of the string and still inside the quotes. Then I'll use the plus operator to concatenate strings. That is, I'm appending another value. And I'll append to the expression args 0. And that means the first value in the args array. Then I'll append another string and I'll put the exclamation mark there. Next, I'll go to terminal, and I'm going to recompile the code with javac and then the full name of the file. Then I'll try to run the code with java com.company.main, and I get an exception. And that's because I'm referencing an item in an array that's empty. The exception is called an array index out of bounds exception, and that's an example of a really long exception class name that Java really likes. But the important thing here is that the index 0 is out of bounds for the array. So to fix that, I'll simply run the code again, but this time I'll add an argument, my name. And this time I get the expected output, hello from Java, David. Now you can do the same thing using IntelliJ IDEA's build and run tools. As I mentioned previously, when you choose build and then build project, you're creating files in this out directory over here. And if I try to run this code right now, I'll once again get the array index out of bounds exception. To fix that, I'll go to the menu and choose run, edit configurations. I only have one run configuration here, it's called main, and it references this main class. For program arguments, I'll enter an argument of Mary. Click OK, and then I'll try to run the code again, and this time I get hello from Java, Mary. So again, this is how you can process and test values passed into command line applications. You'll sometimes hear the terms parameter and arguments used interchangeably, but they do have different meanings. When you declare values that are being passed into a method, those are parameters. When you actually pass the values in from the command line or from IntelliJ IDEA's user interface, those are the arguments. So arguments get passed to parameters. And in Java, you have all the tools you need. And it references this main class. Under program arguments, I'll enter an argument of Mary. I'll click OK, called main, and it references this main out directory over here. And if I try to run this code right now, I'll once again get the array index out of bounds exception. To fix that, I'll go to the menu and choose run, edit configurations. I only have one run configuration here, it's called main, and it references this main class. Under program arguments, I'll enter an argument of Mary. I'll click OK, and then I'll try to run the code again, and this time I get hello from Java, Mary. Hence the expression string, but still inside the quotes. Then I'll use the plus operator over here. I'll change this code to look like this. I'll add a comma space at the end of the string, but still inside the quotes. Then I'll use the plus operator to concatenate strings. That is, I'm appending another value. And I'll append to the expression args 0. And that means the first value in the args array. Then I'll append another string, and I'll put the exclamation mark there. Next, I'll go to terminal, and I'm going to recompile the code with javac and then the full name of the file. Then I'll try to run the code with with Java, com.company.main, and I get an exception. And that's because I'm referencing an item in an array that's empty. The exception is called an array index out of bounds exception. And that's an example of a really long exception class name that Java really likes. But the important thing here is that the index 0 is out of bounds for the array. So to fix that, I'll simply run the code again, but this time I'll add an argument, my name. And this time I get the expected output, hello from Java, Dave. Now you can do the same thing using IntelliJ IDEA's build and run tools. As I mentioned previously, when you choose build and then build project, you're creating files in this out directory over here. And if I try to run this code right now, I'll once again get the array index out of bounds exception. To fix that, I'll go to the menu and choose run, edit configurations. I only have one run configuration here, it's called main, and it references this main class. Under program arguments, I'll enter an argument of Mary. I'll click OK, and then I'll try to run the code again, and this time I get hello from Java, Mary. So again, this is how you can process and test values passed into command line applications. You'll sometimes hear the terms parameter and arguments used interchangeably, but they do have different meanings. When you declare values that are being passed into a method, those are parameters. When you actually pass the values in from the command line or from the IntelliJ IDEA's user interface, those are the arguments. Arguments get passed into parameters, and in Java, you have all the tools you need to receive and process those values. Learn how to program in Java is a combination of learning the base language plus learning about the different libraries, the APIs, that contain all the classes and interfaces that are building blocks for your application. There's a lot of functionality available, and getting to the documentation so you can learn how to use it is critical. IntelliJ IDEA gives you some basic documentation tools that are pre-configured. You can place the cursor in the name of any class that's a part of the core JDK, and then press Ctrl-J on Mac or Ctrl-Q on Windows, and you'll see a pop-up window that shows you some of the documentation, but it isn't complete. If you want the extensive complete documentation, it's best to go online to make sure you're getting the most recent version. I'll go to a browser, and I'm going to search for this string, Java API Docs 13, for the version, and then I'll go to this web page. This page gives you access to everything you need to know about the core libraries that are included with the Java development kit. From here, you can navigate to various classes. So, for example, I'll go to java.net.http, and this is a package that contains classes and interfaces for communicating over the web. Now, to get to this documentation from within IntelliJ IDEA, I'm going to select most of this URL, everything except the index.html part, and I'll copy that to the clipboard. Now I'll go back to IntelliJ IDEA, and with a project open, any project, I'll select File, Project Structure. With my current JDK selected, I'll go to Documentation Paths. Then I'll click this plus button with a little picture of the planet. That means I'm accessing the documentation online. And I'll paste in that URL. I'll click OK, and then OK again. And now I'll click into the name of the class and press Shift F1. And that opens the complete documentation for the class that I selected. From here, I can get to all the methods that are members of that class, fields which contain data in the class, constructors, which are ways of creating instances of the class, and everything else that I might need to know. Once you have the external documentation configured in IntelliJ IDEA, you can find out anything you need to know about any of the classes or interfaces that are delivered with the core JDK installation. Java is a statically typed language. That means that all variables have types that are set when the variable is declared, and when set, a variable's type can't be changed. There are two major categories of data types in Java: primitives and objects. A primitive variable is stored in the fastest possible memory. These include numbers, single characters but not full strings, and Boolean values. Primitive types can contain a single value. They're not complex objects, so they don't have members such as methods or fields. The types for primitives are all lowercase. That's how you can recognize them in your code. And they include these: int for integer, char for character, short and long for different kinds of integers, double and float for different sorts of floating values, and Boolean. A string is not a primitive in Java. It's a complex object, an instance of a class, and we'll get to strings later. You can declare primitive variables in a couple of different ways. The legacy or traditional way of doing it is to start with the data type. In this code, int is the data type, var is the identifier or variable name, the equals character is the assignment operator, and the literal value of 5 is the value I'm assigning. Beginning in Java 10, you can now use inferred typing. This only works on local variables within methods, but when you use it, you're setting the type by deriving it from the assigned value. You start with the keyword var, then once again add the identifier or variable name, and then you assign it the value. The result is a variable named myvar that has a data type of int, and that's derived from the value. Now, you can force the value to have a particular type by adding a bit of alpha notation. If I say var my int equals 5, then it's int. But if I add an f after the number, that means it's a floating value. If I add a d, it's a double value, and if I add an l, it's a long integer. Notice that I'm using lowercase f and d for the floating double, but an uppercase l. A lowercase l would work as well, but it's easy to mistake that for the number 1, and so by convention, Java developers use the uppercase L for a long value. Here are the numeric primitives. In the first column, you see the data type's name, then the number of bits that the data type takes to store in memory. And then in the minimum and maximum columns, you see the ranges of the types. All of the numeric types support signed values. That is, you can have negative and positive values. For floats and doubles, take a look at the documentation for the minimum and maximum values. The double primitive type is frequently used to represent currency values, but as I'll show you later, that's not always the best approach. There's also a set of classes in Java called wrapper classes, and these are designed to support conversion and formatting of numeric values. Here they are. For each primitive data type, you have a matching wrapper class. In most cases, the name of the wrapper class is the same as the primitive data type it wraps, but there are exceptions. The wrapper class integer is for a primitive int, and the wrapper character is for a primitive char. These classes can do a lot of work for you. For example, you can use them to parse strings and convert the values. So if I start off with a string, such as 156.5, and I want to turn it into a true numeric, I can use the class double, which has a static method called parse double. Static means you call the method from the class itself, not from an instance of the class, and it returns the value cast as a double value. Once you have that double value, you can then use it to convert to other types, because the double object instance of the double class has member methods, a byte value, int value, float value, and a string to convert back to a string value. Notice in this code, I'm using inferred data typing by starting with var, and I can do that because I know what type those methods are returning. One other thing about primitive values. All primitive values in Java are signed. As I mentioned previously, that means that they support both positive and negative values. But there are times when you want to do unsigned operations. And to support this, the long and integer wrapper classes have methods that support unsigned operations. In this code, I'm starting with a value of 3 billion, and I call a static method of the integer class called parse unsigned int. It returns a value. Now I can output it, but then if I want to divide that value, instead of using conventional division, I would use the method divide unsigned and pass in the value I want to divide by. And I get the result. What's actually happening in the background is pretty interesting, and I encourage you to try typing out this code and running it to see what those values are. In order to test out some simple code, I'm going to use Java's JShell environment. As I mentioned previously, you can run JShell from any command line or a terminal window, but if you're using IntelliJ IDEA, you can use the terminal window there. You can use any IntelliJ IDEA project for this exercise. The goal is simply to get to this screen, and from there, click terminal, and then type JShell and press enter or return. That should take you to the JShell environment. I'll double click on this bar, and that expands my terminal window to more full screen. First, I'm going to declare a number of primitive values using explicit data typing. I'll start off with type b equals 1, and that creates a byte value. I can see that value just by typing the name of the variable and pressing enter or return. That's something specific to JShell. It doesn't work with actual Java code. Next, I'll create a short integer. I'll say short sh equals 1, and then I'll set an int with int I equals 1. So these three variables all contain the same value, but they take up different amounts of memory. The byte takes up the smallest amount of memory, the short a little bit more, and the int a little bit more than that. Let's also try out some inferred typing. I'll create a variable starting with var. I'll set it to v and give it a value of 1. Next, I'll create a variable called long value, and I'll set the literal value using underscores to separate the thousands. Then I'll add the L at the end to indicate that that's a long integer, and I get the value. I can do the same thing with a float like this. I can say var, float value. Then once again, I'll just add a whole bunch of zeros and some fractions, and I'll add an f at the end, and that gives me the float value. Anytime you want to see a value, in JShell you can simply type the value's name, or you can use system.out.println like you would in real Java code. And that outputs the concatenated string. Each of the wrapper classes for the primitives has constant values for max value. So let's, for example, set a byte value of 127. Then I'll type b to see what the value is, and then I'll look at the byte max value and compare the two things. I'll say if b is less than byte.max value, then I'll start a code block with an opening brace, then I'll say b++, meaning add one value, and then I'll add the closing brace. Then I'll test b, and I'll see that it hasn't been incremented. You can do the same thing with integers, shorts, longs, floats, and doubles. So again, these are the different ways to declare primitive values. You can either use explicit typing, or if you're declaring a variable within a method, you can use inferred typing. If a variable's data type isn't a primitive, then it's an object of some kind. When you build Java applications, you're creating classes. A class is essentially a template for creating objects. So for example, if I wanted to create a pattern where I could store information about types of clothing, I might create a class called clothing item. That clothing item class could have fields for data values and methods that knew how to do stuff. When you create an object variable, you're creating an instance of one of those classes. And because the classes can define fields for data values and methods for actions, when you create the object that's an instance of the class, it has those fields and methods. In Java, a field is a variable that's a member of a class. A local variable is a variable that you declare inside of a method, while a field is a variable that's declared after the class declaration. And we'll talk about class syntax later on, but for now, you just need to know that an object is an instance of a class. In order to declare an object variable, you once again have a couple of options. You can declare a variable without instantiating its value. In this example, I'm setting the data type explicitly, and then I'm giving the variable an identifier or a name. I'm not initializing it. That is to say, I'm not giving it an initial value. And in Java, when you declare an object but you don't assign its value, its default value is something called null, meaning the absence of a value. If you like, you can declare and initialize variable at the same time. In this example, I'm once again using explicit typing by setting the data type at the beginning of the statement and then giving the variable a name. And then I'm using the keyword new, followed by a call to the class's constructor method. The constructor method's name and the class's name are always the same. And a class can have more than one constructor, and sometimes you can pass values into the constructor. So now my object variable item is an instance of the class clothing item. This is the traditional initialization syntax, where you use explicit data typing. And it's still required in some contexts, even though starting with Java 10, we now have inferred typing. But in the context where you can use inferred typing with objects, here's what it looks like. I start with the keyword var, then the identifier, then once again the keyword new, and the constructor. This code has exactly the same result as with explicit typing. Item is an instance of the clothing item class. And in this example, the data type has been derived from the constructor that I used. Again, type inference works starting in Java 10, and it only works for local variables inside methods or within JShell. Once you've created an instance of a class, you have access to its members. You can set its data values, and you can call its methods. In this example, my clothing item class has two methods called setType and displayItem, and I'm calling them each. SetType to set a value in the object, and displayItem to execute some functionality. So that's how you can create object variables by using either explicit type declarations or by inferring the data types based on the value that's assigned. Primitive numeric types are useful for storing single values in memory, but specifically, double and float types aren't always entirely precise. That's because the way they're stored in memory doesn't always map exactly to the value. You can look at the documentation for the details of this, but it's better just to see an example. I'll go into JShell, and I'm going to create a variable named value that I've explicitly typed as a primitive double, and I'll assign it a value of .012. Now I'm going to add that value together 3 times, and I'm going to create a new double variable that I'll call psum. I'm using the letter P for primitive, and I'll give it a value of value plus value plus value. Now before I show you the result, take a guess at what that should be. You might guess it's .036, but instead you get .036 and a whole bunch of zeros followed by a number at the end. So particularly when you're working with currency values, this can be a big problem. If you add enough values together, the rounding errors start mounting. And so to fix this, Java provides a class called Big Decimal. There are actually 2 of these classes. There's one called Big Integer and one called Big Decimal, but Big Decimal is specifically useful for taking care of this precision problem. To use Big Decimal with a number, first convert the number to a string and then turn it into a Big Decimal object. I'll create a variable that I'll name string value, and I'll use the double bracket classes to use string method. I'll pass it value. So now I have a string of 0.012, and that's not a number anymore. Then I'll create a big value variable, and I'll initialize that as an object with new, and then I'll call a constructor for the big decimal class, and I'll pass in the string value. The big value is now an object. It contains the same as the original value. Now I can add that value together a couple of times. I'll create a new variable that this time I'll call big sum, and I'll get it by calling big value, and then I'll call a method named add. And I'll pass in big value again, and then to add it another time, I'll call the add method again, and I'm chaining the calls to the methods together. And now big sum has a value of 0.036. If I then want to turn that back into a primitive, I can create another variable that I'll simply name sum, and I'll call big sum.double value. And then I can output the result by simply typing sum. It takes a few extra steps to properly handle numeric values in Java with the big decimal class, but this approach gives you the precision that you frequently need. In Java, you can make copies of and convert numbers to different types. Certain conversions are automatic. When you're converting from a more precise to a less precise type, it's known as widening. But when you narrow the type, you need some special syntax. Let's take a look at some conversions that widen it. I'll start off with a short integer that I'll set to a value of 100. Then I'll make a copy of that value, but set the new version as int I equals sh. I and sh contain the same value, but the int variable takes up more memory than the short. Because I'm expanding the amount of memory I'm using, I'm widening the type, and I don't need any special syntax. Here's another example. I'll create a long integer that I'll call long value, and I'll assign it to I. And once again, this is an automatic conversion because I'm widening the value. But now I'll try to take that long value and turn it into a short value. The short value equals, and I'll pass in long value, and I get an error. I told that these types are incompatible, and that the conversion could be what's called lossy. That is, I could lose data. If I want to do this kind of conversion, I need special syntax. It looks like this. I'll say short value equals, then I'll put the type in again inside parentheses. And now the short value contains the same number. But because the short and long integer types have very different ranges, this operation could result in losing some data. By adding the special syntax, you're saying, I know I can lose data, but I know what I'm doing. Declaring the type inside parentheses is sometimes called casting syntax. It's forcing the type of the value, but you're not really casting. That term really refers to objects that are instances of classes. This is conversion. You're making a copy of the value and setting the new variable's type explicitly. I encourage you to try different versions of this. For example, start off with an integer and try converting it to a byte, or start with a double and convert it to an integer. Either way, you could be truncating value or losing data. As a Java developer, you want to know your primitive types and know when you can automatically widen, going from a type that uses less memory to one that uses more, and when you're explicitly narrowing the value. Java supports the standard mathematical operators that you expect to see in all programming languages, but it also supports more complex operations using a special class called math. I'll start this demo by declaring 2 integer values. I'll use inferred typing, starting with the var keyword, and I'll set the first variable to a name of value 1 and a value of 56. I'll bring back that command by pressing the up arrow, and add those values together. I'll create a new variable that I'll call result1. I'll get that value with int value1 plus int value2. And I get a result of 98. Now I'll declare another variable that I'll call result2. I'll get that value by subtracting values. I get 14. The next one, I'll have a variable called result3, and I'll multiply with the asterisk. And then finally, I'll get result4 with division, with a /. So those are the simple mathematical operators. If you want to do something more complex, you can use the math class. And to demonstrate that, I'll create a double variable. I'll call it double value. And I'll set it to a value of negative 3 dot and then 5 nines. Now I want to round that value. I'll create a new variable that I'll type as a long, and I'll name it rounded. I'll use the math class and call it the round method. And I'll pass in double value. And I get a value of negative 4. Now I could also call a method named ABS for absolute. This will return a value typed as double. And I'll get that value with math.abs. Once again, I'll type in double value. And I get a positive 3.99999. There are many other available methods in the math class. You can go to the documentation on this webpage, click on method, and see a complete listing there. A variable with a primitive data type Boolean can have a value of either true or false. In some languages, the values true or false can also be represented as numeric values, but in Java that's not the case. The keywords true and false are the only possible Boolean values. To create a Boolean variable explicitly, start with the type name, Boolean, then set the variable name or identifier, and assign either true or false. You can also use inferred typing. I'll create a variable starting with var. I'll call this one b1 and I'll set it to true. And I'll create another one called b2 and set it to false. So those are also variables with a primitive data type Boolean. If you declare a Boolean value without setting its initial value, it'll default to false. So if I create Boolean b3, I see that it's false. You can reverse a Boolean value, set it from true to false or false to true, using the negation operator, a single exclamation mark. So I'll create a variable called b4, and I'll set it to a value of exclamation b1. b1's target is true, and so b4 is false. A Boolean expression is some expression that resolves to true or false. I'll create a variable called I that I'll set a value of 0, and then I'll say var b5 equals, and then in parentheses, I'll compare I to a value of 0, using exclamation equals 0, and b5 is false, because I does have a value of 0. Exclamation equals is the inequality operator in Java. If you have a string that represents a Boolean keyword, true or false, you can parse that string to get an actual Boolean value. I'll create a variable that I'll call s, and I'll set its value with the word true in double quotes. The value in quotes means this has to be a string. Then I'll create a new variable that I'll call b6, and I'll get that value using the wrapper class Boolean. I'll call it parse Boolean method, and I'll pass in s. And b6 is now a primitive Boolean value of true. Check the documentation for more info about the Boolean primitive type and its associated wrapper class Boolean with an uppercase B. Java distinguishes between characters and strings. A character is a primitive data type that consists of a single character. A string is a complex object that references a collection of characters. You can declare an individual variable as a character, either explicitly using the char keyword, then I would assign a variable name or identifier, and then I can assign a literal value, a single character wrapped in single quotes. You use single quotes for characters and double quotes for strings. You can also use inferred typing. This time I'll use var, and I'll say c2 equals 2, again with single quotes, and then I'll create a third variable named c3. You can also create character values using literals that are Unicode expressions. I'll start with char, I'll name this variable $, and then I'll use \u for Unicode, and then a 4-digit value. 0024 is the value for the $sign. If you want to convert a character to an upper or lowercase value, you can use the static method of the character wrapper class. So for example, I might create a variable named upper, and I'll use character.to uppercase, and I'll pass in c1. That's meaningless with a numeric value, so now I'll say c1 equals lowercase a. I don't have to set the type again because I've already declared the variable, just resetting its value. And then I'll once again say upper equals character to uppercase, and this time I get an uppercase a. You can create an array of characters like this. I'll start with char, and then the opening and closing brackets mean create an array, a collection of values. I'll name this variable cars, and I'll use this expression, start with a brace, and then H, E, L, L, and O. Each of these values is a single character wrapped in single quotes, therefore it's a primitive character, but now the collection of characters gives you the entire word. If you wanted to turn that array into an actual string, you can say string s equals new string, and pass in the array. And now you actually have a string, and you know that because it's wrapped in double quotes. And if you want to turn that back into a character array, you can create a variable named car array, and get that value with s.to car array. And now you're back to the original array of primitive values. So an array of characters can be used to code a string, and a string can be turned into an array of characters. Knowing that a string is a complex object that references a collection of primitive single characters is incredibly valuable as you learn how to work with strings in Java. As I've described previously, Java is a C-style language, and it shares the same operators as other such languages, such as C and C++. You can roughly categorize operators in Java under these groupings: equality operators, assignment operators, mathematical operations, logical operators, and the special ternary operator that lets you abbreviate an if-then statement. I'll start with assignment of math operators. Let's say that we have an integer value. If you declare an int value, and you set its type explicitly, but you don't assign it a value, it'll default to 0, and that's the same for all primitive numeric types. On the other hand, you might explicitly assign a value and use the keyword var and let the type be inferred. And as I've described previously, this only works for variables that are local within methods and only starting with Java 10. So I've assigned this value. Now I want to do some mathematical operations. So in each of these statements, I'm creating a new variable that I'm calling new value, and I'm getting its value using a mathematical expression. This is addition, I get 15. Subtraction, I get 5. Multiplication, I get 50. And division, I get 2. There's also the modulus operator, the percent character, and this returns the remainder of a division operation. Now, with the modulus operator, you always get back an integer. There are times when you don't want to use the var keyword. For example, if you divide an integer by an integer and you don't specify the type that you want to return, you'll get back another integer. And if the dividing operation might have returned a fractional value, the result will be truncated. You'll lose data. And so that would be an example of a time when you might want to explicitly say, this is the type of data I want back. Here are some other assignment operations. Java supports plus plus and minus minus to increment the value or decrement it by a value of 1. You can also use incrementing and decrementing operators that look like this. You can also increment or decrement and assign at the same time. So int value plus equals 5 gives you 15, and so on. When you use the plus plus and minus minus operators, the results will differ depending on where you put the operators in your code. When you put the operator after the value, that's called a postfix. In this example, I'm outputting a value of 10, because that's the value when I output it, and then I'm executing the mathematical operation. When the statement is complete, the new value is 11. If I want to change the value before I output it, I would use prefix notation with plus plus int value, and then the output and the new value would be the same. Java has a number of equality operators. The equality operator itself is a double equal sign. A single equal sign is the assignment operator, double equals is equality. So if I have two variables called this and that, this expression would return a value of true. Inequality can be calculated using the exclamation mark equals operator. Some developers call the exclamation mark the bang operator. So that would be bang equals. But again, this is just the inequality operator. When you're working with numeric values, you can also use the greater than, less than or equal to, and less than or equal to operators. There's also a special operator called instance of that lets you look at an object and ask, is this object an instance of this class? We'll talk about that more when we get into polymorphism and other object-oriented concepts later in the course. When you want to compare two strings, you have to do something special. You might be tempted to use the double equals operator, and that sometimes works and sometimes doesn't. The bottom line, though, is it's not the right way to do it. When you want to compare strings, you should use a method called equals to compare one string to the other. In this code, I have two strings that have the same values of hello, and I'm asking does string 1 equal string 2? And the answer is yes. Those two strings, even though they aren't the same object, do have the same value. Logical operators look like this. The double ampersand is a logical and condition. The double pipe character is a logical or. And the question mark equals operator is a special operator called a ternary operator that lets you do an if-then statement in shorthand notation. It looks like this. Let's say you have a variable named I, and you want to find out whether it has a value of 1. This code means if I has a value of 1, then the message is there's 1. Otherwise, the message is there are, and then the actual number. And then I'm outputting the message. Again, you can write this same logic using the full if-then statement, but there are frequently advantages to this in shorter notation. So those are the main operators in Java. There are others, and I encourage you to look at the documentation online to learn about all of Java's operators. String values String values, that is bits of text, are among the most common bits of data that you need to work with in any programming language. A string in Java is an instance of the string class. There are a few ways of creating them. You could explicitly declare the type string with an uppercase S, and then you would assign an identifier and a value. Say this is a string. You can also use type inference, starting with the var keyword. Say this is another string. The Java compiler determines that this is a string because of the double quotes surrounding the characters. And because this is an instance of the class, you can also use constructor notation like this. I could say var, I'll use type inference again, this time I'll name the variable S3, and I'll instantiate and initialize this with new string. And then I'll pass the value into the parentheses. Any of these three bits of notation will result in an instance of the string class. As I showed previously, a string has a reference to an array of characters, and you can get that array of characters by calling the method of the string class called toCharArray. When you append values to a string, it's called concatenation. The plus character serves as the concatenation operator. It's also the addition operator for numeric primitive values, so we like to say that the plus character is overloaded. It serves more than one purpose. I'll create a new string that I'll call S4. I'll give it a value of shirt size. I'll add a space after the colon. Then I'll create a variable called S5, and I'll give it a value of M for medium. And then I'll create a third string, and I'll concatenate those values together along with some literal strings. I'll start with S4, and then I'll append S5, and then I'll append a literal string of QGY, a colon and a space, and then a numeric value of 4. And the result is a concatenated string. You can also append a value to a string using the plus equals operator. So I'll say S6 plus equals, and then comma, very elegant. There's one very important thing to remember about string objects in Java. They are immutable. Their value really can't be changed. So when you append or replace a string's value, you're really discarding the existing object and creating a new one in memory. And one of the rules of working in Java is that you want to reduce the number of objects you're creating. For this reason, there are other better techniques for building strings that I'll demonstrate in the next video. But before that, I want to show you a couple of other things you can do with strings. Remembering that a string is an instance of the string class, you have access to a whole bunch of different methods. So for example, let's say that I wanted to uppercase a value. I could use the method toUppercase. I'll create a variable that I'll call upper, and I'll get its value from S6.toUppercase. Or I could get a character at a particular index location, and that returns the letter T. Notice that the letter T is the fifth letter in the string, and that's because indexing in Java starts at 0. And the last thing I'll show is the use of the getBytes method, which returns an array of bytes. Check the documentation for the string class for all the tools that you have available for working with strings in Java. As I described previously, a string object in Java is immutable. Its value can't be changed. So when you append or replace a string's value, you're really discarding the existing object and creating a new one in memory. To create a complex string from scratch without leaving a trail of temporary string objects in your wake, you can use the string builder class. First, a bit about builders. A builder is a software pattern that can be used to create or build an object. First, you create the builder itself, and then you call a series of methods to create the target object. In JShell, I'll create an instance of the string builder class using type inference. I'll name the variable SB, and I'll initialize it with new string builder, and I'll pass in an initial string of welcome. Now I'll append the value with sb.append, and I'll pass in space and to California. The output shows me the current context of the string builder, but to get that into a real string, I'll create another variable that I'll call S, and then I'll call the builder's toString method. And now I have a real string object. You can also call the append and other methods of the string builder class multiple times. Each time you call the method, it returns a reference to the builder, so you can chain the calls together. I'll create another new string builder. This time I'll use explicit typing. I'll name this one B, and I'll initialize this as an empty string. Now I'll call B.append, and I'll pass in shirt size. Then I'll call append again after a dot, and I'll pass in M. Then I'll call it again, and I'll call it one more time. And then once again, I'll get the string that it's built. In the context of a real Java class, you can add new lines after each of the calls to the append method to make the code more readable. That's not as easy in JShell because the new line would be interpreted as the end of a statement. So let's move this code to an IntelliJ IDEA project. First, I'll save this code out to a file. I'll start with the /save command, and then I'll call the file builder.java. Now I'll close the terminal window, and I'll see that I have this new file builder.java. I'll select all of this code and copy it to the clipboard, and I'll close this project, and I'll create a brand new project. I'll accept all the defaults. I'll create the project from the template, and finish. And then inside the main method, I'll paste that code into place. Now I'll go to the multiple append calls, and I'll just add new lines after each call. And then I'll output the result. I'll use this code template as out, and that expands the system.out.println line, and I'll output the string. And I'll see that it runs successfully. Now as you can see, the code in a class is built from implementation. IntelliJ IDEA gives you all kinds of great tools for building, automating, and debugging your code. So if you want out in real IntelliJ IDEA projects, and in order to do that, you're going to have access to the exercise files. So in the next video, we'll take a break from Java, and I'll show you how to get the exercise files from Git. The exercise files from this course are available in a public GitHub repository at the web address you see here. You can clone this repository so you can work along with the files as I do the demonstrations on screen. In order to work with these files, you need to install Git on your computer. If you've never used Git before, I highly recommend it. It's used by a lot of software developers, and you can get the software from this website. If you're not sure whether you already have it on your system, you can go to a command window or terminal and type git --version. After installing Git on your computer, go to the repository on the GitHub website, then click on the clone or download button and copy this URL to the clipboard using this button. Then go to the IntelliJ IDEA welcome screen, click checkout from version control, choose Git, and paste the URL into place. If you're prompted to create a GitHub membership, you can do that for free on the GitHub website. But then you should be able to test and see that you can make a successful connection, and you should then be able to clone the repository. When the checkout is complete, click yes to open the project in IntelliJ IDEA. Once the project is open, go to the project window from the tab at the top left, open the stream to the source directory. From there, you'll see that there's a subdirectory called com, which has a subdirectory called company, and within that, a Java class called main. This repository has starting branches for each of the videos. In order to find the branches, go down to the lower right corner and click on this icon, and then when the window appears, drag to expand it upward. Under remote branches, you'll see the master branch, that's what I'm on right now, and then beginning states for some of the videos and ending states. The ending states for those exercises end with the letter E for end. Let's say I'm in the fourth video of the fourth chapter. I would go to 0404, and I'd select checkout as, and click OK. And depending on the exercise, you might see an immediate change to your code. You might see other files appear over here in the project window. In order to test the application, go to the starting class named main, right-click on it, and choose run main.main. And that will build and run the application for the first time. After you've done that once for each branch, you should then be able to rerun it from the run button on the toolbar up here. When you make any changes to your code, you'll have made changes that need to be committed before you can load up another branch. I've made just a single character change to this code. Then I'll go to the bottom of the interface and choose version control. I'll open up my default change list and click on main.java. Then, to see the differences between the original branch and the current version, I'll press Command-D on Mac or Control-D on Windows, and it'll show me where my changes are. I'll close that window, and then I'll click on the checkmark icon, which means I want to commit my changes. You must put in a commit message. You can simply put in my changes, and then click the commit button. If at any point you're prompted to push your changes to an origin or remote repository, don't even try. If you're not registered as a contributor to the GitHub repository, you won't be able to do it anyway. These exercise files are yours for use on your local computer as you learn how to program in Java. I've described previously how to append primitive values to strings. To get the default representation of a primitive value, you don't need any special syntax. You just append it using the plus operator as shown here. I'm now working in a branch in my GitHub repository that's designed as a starting branch. As always, you can go to the ending version of this exercise anytime you like. I'll run this code and see the output. As long as there's at least one string in a series of values, this sort of conversion happens correctly. I'll create a new string and I'll use explicit typing. I'll name the string how many, and I'll give it a value of 20, and then I'll append a string of things. And then I'll output that variable. And I get 20 things. But here's what happens if you try to append two numbers in the same way. If you use explicit typing, I'll name this result 2, and I'll add 10 plus 20. And if I move the cursor over that statement, I'll see the message incompatible types. And if I try to run it, I'll get a compiler error. If I try to change the type inference, that will appear to work, but instead of creating a string, I'll be creating a number, the sum of 10 plus 20, not what I wanted. So again, the rule is, as long as you have at least one string in the listing of values, you will be able to do that conversion. You can directly convert primitive values in other ways. You can use the wrapper classes. Each of them has a two-string method. So for example, I can create an integer, I'll name it int value, and I'll give it a value of 42. Then I'll create a new variable that I'll name from int, and I'll use the integer wrapper class and call the toString method. And notice that there are a bunch of versions of this method. I'll pass in int value as the one and only argument, and then I'll output that to the screen with system.out.println. I'll try that with another type of primitive. This time I'll create a boolean. I'll name this bool value. I'll give it a value of true. And I'll name the new variable from bool. I'll use the boolean wrapper class and call the toString method and pass in bool value. And then I'll output that. And there's the value of true in the console. And then finally I'll do one more. I'll create a long integer containing the value 10 million. The underscores there are just for readability. You're still creating a real number. And then I'll call long.toString and pass in my variable, and I'll output the result. And there's the output in the console. So that's variable, and I'll output the result. And there's the output in the console. So that's the easiest way of creating strings from primitive values. With all of these tools, you'll get the default string formatting. But there are lots of other tools for customizing the formatting, and I'll show you those next. I've previously described how to convert a numeric value to a string using the primitive data types helper or wrapper classes. But you can also use the set of formatter classes to format numbers and currency values. You start by creating instances of these classes. I'll create one that I'll call numF, and I'll get that object using this expression, number format.getNumberInstance. There are a number of different methods that return instances of various objects. Now notice, when I reference the number format class, that there's an import statement that's being generated automatically by IntelliJ IDEA. I'll talk more about imports later on, but what's important to know now is that there's a certain set of classes in Java, such as the string class and those wrapper classes, that don't have to be explicitly imported. They're always available to the compiler. All other classes have to be imported. An import statement is just an instruction to the compiler that says, this is where you can find this class. It's in this package. So I have my numF object. Now, to use it, I'll use this expression. I'll start with system.out.println, and I'll add in a literal string of number, and I'll append to that numF.format, and I'll pass in the double value that I've already result is that I see commas separating the thousands. Now, you may see something different on your screen. If you're working in another country that uses different numeric formatting by default, you might see dots where I see commas and commas where I see dots, and that's to be expected. So that's a simple number format. Let's say that I wanted to force that number to an integer. I'll create another variable that I'll call intf. Once again, I'll use the number format class, and this time I'll call the method getInteger_instance. Notice there's also getCurrency_instance, getPercent_instance, and getCompactNumber_instance. Now I'll come up here and duplicate this code. In IntelliJ IDEA, you can duplicate a line of code by pressing Command D on Mac or Control D on Windows. And I'll move that code down, and I'll change this to intf. And this results in rounding the value before it returns the value as a formatted string. If I want to entirely suppress the separators between the thousand groupings, I can call a method of the formatter object. I'll call intf.set. You start by creating instances of these classes. I'll create one that I'll call numf, and I'll get that object using this expression. Number format.getNumberInstance. There are a number of different methods that return instances of various objects. Now notice, when I reference the number format class, that there's an import statement that's being generated automatically by IntelliJ IDEA. I'll talk more about imports later on, but what's important to know now is that there's a certain set of classes in Java, such as the string class and those wrapper classes, that don't have to be explicitly imported. They're always available to the compiler. All other classes have to be imported. An import statement is just an instruction to the compiler that says, this is where you can find this class. It's in this package. So I have my numf object. Now, to use it, I'll use this expression. I'll start with system.out.println, and I'll add in a literal string of number, and I'll append to that numf.format, and I'll pass in the double value that I've already declared above. The result is that I see commas separating the thousands. Now, you may see something different on your screen. If you're working in another country that uses different numeric formatting by default, you might see dots where I see commas and commas where I see dots, and that's to be expected. So that's a simple number format. Let's say that I wanted to force that number to an integer. I'll create another variable that I'll call intf. Once again, I'll use the number format class, and this time I'll call the method getInteger_instance. Notice there's also getCurrency_instance, getPercent_instance, and getCompactNumber_instance. Now I'll come up here and duplicate this code. In IntelliJ IDEA, you can duplicate a line of code by pressing Command D on Mac or Control D on Windows. And I'll move that code down, and I'll change this to intf. And this results in rounding the value before it returns the value as a formatted string. If I want to entirely suppress the separators between the thousand groupings, I can call a method of the formatter object. I'll call intf.setGroupingUsed, and I'll pass in a value of false. And then I'll execute this line of code again. And this time I get the number without any extra notation. You can also control the locale of your formatting. A locale is an object, and it's an instance of the locale class. You can get the default locale like this, with locale.getDefault, and once again, this is a class that has to be imported to be used, and then you can create a formatter object that uses that locale. And then you can output the result like this. And once again, you get commas between the thousands. Now, if you want to create a different specific locale, you can change this code. This time, I'll use new locale, and I'll pass it two strings. The first is the language, and that's in lowercase, and the second part is the country. always in uppercase. So now I want to format this number using the formatting that's default to the country of Germany. It's DE for Deutschland. And the result is dots where I used to see commas, and commas where I used to see dots. If you want to format currency values, you can create a currency formatter object, and you can get that once again from the number format class, and this time called getCurrencyInstant. And then you can output the result like this. And once again, you get commas between the thousands. Now, if you want to create a different specific locale, you can change this code. This time, I'll use new locale, and I'll pass in two strings. The first is the language, and that's in lowercase, and the second part is the country, and that's always in uppercase. So now I want to format this number using the formatting that's default to the country of Germany. It's DE for Deutschland. And the result is dots where I used to see commas, and commas where I used to see dots. If you want to format currency values, you can create a currency formatter object, and you can get that once again from the number format class, and this time called getCurrencyInstant. If you want to pass in a local locale, you can do that. I'll pass in the German locale again. Then I'll output currency formatter by format, and I'll pass in my numeric value. And I get German formatting with the euro symbol at the end of the string. If I don't pass in the locale object, then I'll get my default locale, and because I'm in the United States, I get dollar formatting. And finally, you can create custom formatting with an object called a decimal format. I'll name this simply DF for decimal format. And I'll initialize it with decimal format, and I'll pass in something called a mask, starting with $00.00. And this means no matter what the numeric value is, make sure that there are at least two zeros before the dot, and that the dollar sign is a literal string. And then I'll output df.format, and I'll pass in a literal primitive value of 1. And the result is $01.00. Take a look at the documentation for the decimal format class for more information about how to custom. And the result is $01.00. Take a look at the documentation for the decimal format class for more information about how to custom format your numeric values. String interpolation is the process of evaluating a string literal containing one or more placeholders. In Java, you can do this with a method of the string class named format. In this code, I have 4 different variables, 3 strings and 1 numeric value. I'm going to create a string template. I'll name a template, and I'll give it this value. Start with a literal string of clothing item. Then, for each placeholder, for a string, I'll use the expression %s. You can add as many different literal strings and placeholders as you need to. I'll put the size here, and the color here. You use %s for strings, but if you have numeric values, you can use %p for integers or %f for floating values. I have a floating value of $14.99, so I'll put %f here. And if I want to add a dollar sign before it, I can put it right here as literal. Now I'll combine that template with variable values using string format. I'll create a new variable that I'll call item string. I'll call string.format. And notice the signature here. This is telling me that I need to pass in a format or a template, and then I can pass in as many other arguments as I need to. The ... in the method signature means variable number. You have to add in as many other arguments as you have placeholders, and you have to make sure that the types of values you pass in are compatible with placeholders in the order in which they're declared. So I'll start by passing in my template, and then I'll pass in the item, the size, the color, and finally the price. And that matches the order of the placeholders in the template. And then I'll output the result. And there's the result in the console. I see the type of item, I see the size, I see the color, and I see the price, but notice that the fractional value isn't formatted the way I would like. That turns out to be a pretty easy thing to fix. I'll go back to my placeholder for the floating value, and I'll add in .2 between the % character and the letter F, and that means truncate this to 2 decimal places. And I'll run the code again, and I see the result I'm looking for. So string interpolation is actually pretty easy to do in Java as long as you know which floating value, and I'll add in .2. String interpolation is the process of evaluating a string literal containing one or more placeholders. In Java, you can do this with a method of the string class named format. In this code, I have 4 different variables, 3 strings and 1 numeric value. I'm going to create a string template. I'll name it template, and I'll give it this value. Start with a literal string of clothing item. Then, for each placeholder, for a string, I'll use the expression %s. You can add as many different literal strings and placeholders as you need to. I'll put the size here, and the color here. Yes. Start with a literal string of clothing item. Then, for each placeholder, for a string, I'll use the expression %s. You can add as many different literal strings and placeholders as you need to. I'll put the size here, and the color here. You use %s for strings, but if you have numeric values, you can use %d for integers or %f for floating values. I have a floating value of 14.99, so I'll put %f here. And if I want to add a $sign before it, I can put it right here as a literal. Now I'll combine that template with the variable values using string format. I'll create a new variable that I'll call item string. I'll call string.format. And notice the signature here. This is telling me that I need to pass in a format or a template, and then I can pass in as many other arguments as I need to. The ... in the method signature means a variable number. You have to add in as many other arguments as you have placeholders, and you have to make sure that the types of the values you pass in are compatible with your placeholders in the order in which they're declared. So I'll start by passing in my template, and then I'll pass in the item, the size, the color, and finally the price. And that matches the order of the placeholders in the template. And then I'll output the result. And there's the result in the console. I see the type of item, I see the size, I see the color, and I see the price, but notice that the fractional value isn't formatted the way I would like. That turns out to be a pretty easy thing to fix. I'll go back to my placeholder for the floating value, and I'll add in .2 between the % character and the letter F. And that means truncate this to 2 decimal places. And I'll run the code again. And I see the result I'm looking for. So string interpolation is actually pretty easy to do in Java as long as you know which method. And I'll run the code again. And I see the result I'm looking for. So string interpolation is actually pretty easy to truncate this to 2 decimal places. And I'll run the code again. It's formatted the way I would like. That turns out to be a pretty easy thing to fix. I'll go back to my placeholder for the floating value, and I'll add in .2 between the % character and the letter F. And that means truncate this to 2 decimal places. And I'll run the code again. And I'll add in .2 between that turns item, I see the size, I see the color, and I see the price, but notice that the fractional value isn't formatted the way I would like. That turns out to be a pretty easy thing to fix. I'll go back to my placeholder for the floating value, and I'll add in .2 between the % character and the letter F. And that means truncate this to 2 decimal places. And I'll run the code again. And I see the result I'm looking for. So string interpolation is actually pretty easy to do in Java as long as you know which method you need to use. For more information about string interpolation, place the cursor in the name of the method format and press Shift F1, and that'll take you out to the documentation for that particular method. You'll learn about formatting strings and the arguments that you can pass in to create your own formatted strings. There are many scenarios where you need to compare strings to each other, and using simple equality operators looks like it should work, but it doesn't work the way you might expect. I'm starting this exercise with 2 strings. String variables, one declared with explicit type and the other with an inferred type. They both have the same value of hello and an exclamation. I'm going to create an if statement. In Java, the if keyword is followed by a pair of parentheses, and the parentheses need to wrap an expression that evaluates as true or false. I'm going to be doing this the wrong way. I'll say if S1 matches S2 using the double equals operator. The double equals operator works for equality with primitive values, but it's not the right way to do it with objects, and I'll show you why. If those 2 values match, I'll output they match. I'll add an else clause here, and if I get back false, then I'll say they don't match. And I'll run this code. Now, in this example, I get back they match, and it means we're not doing it the right way. But now I'm going to create 2 more variables using object creation syntax. I'll create an S script. copy of this bit of code and paste it down here. And I'm going to compare S3 to S4 this time. And I'll run that code, and this time I get back they don't match. So even though these two objects have the same string value, Java says they are the same thing. And this makes sense once you understand what's happening in the background. In the first example, you're letting Java figure out the best way of creating the strings. Strings are objects, and object variables are references. They refer to an object at a particular memory location. When you assign a string variable to a literal or existing known value, Java looks up that value in a table it maintains in memory. If it finds an existing object that represents the same value, it assigns the new variable as a reference to that object instead of creating a new one. This process is known as interning, and you can actually force it to happen by calling the intern method for that object instead of creating a new one. Memory. If it finds an existing object that represents the same value, it assigns the new variable as a reference to that object instead of creating a new one. This process is known as interning, and you can actually force it to happen by calling the intern method from the string class. When you use the object creation syntax, you're forcing the creation of a new object. The double equals operator, when used with objects, doesn't compare values. It asks whether the two variables reference the same object. So that just isn't the right way to do string comparisons. Instead, you should always use a method named equals, and it looks like this. If s3.equals s4, I'm passing s4 in as an argument to the method. Then, once again, I'll say they match. I'll just copy this bit of code up here, and I'll paste it into place. And I'll run that code, and this time I correctly get back they match. Once you start using methods for comparison, you have some flexibility. So you can do a case inset of comparison with a different method. I'll create create a variable named s5 that has value of hello, all lowercase. I'll copy and paste this bit of code. This time, I'm going to compare s3 to s5. And initially, I get back they don't match. But now instead of using the equals method, I'll use something called equals ignore case. And now I get back they match as the last comparison.
Begitu antum.
The thing to take from this exercise is that the double equals operator, when used with object variables, asks the question, do these two reference variables reference the same object in memory? But when you're comparing strings, that's not the question you're interested in. You're asking whether the two values match. Java's string class includes many methods that you can use to parse data and find substrings. I'm starting with a string of welcome to California. Let's say I want to find out how long that string is. I could use the length method. I'll use some system output, and then I'll pass in length of string, and I'll append the expression s1.length. And that's a method, so use the parentheses at the end. And I get back a numeric value. If I wanted to find the location of a particular substring, I could use the method index of. I'll create a variable called position. I'll call s1.index of and pass in California. And then I'll output that using a concatenated string. And I find out the California. starts at index 11. Let's say I wanted to find out what value did start. Start at 11. I can create a variable, I'll call it sub, and I'll call it s1.substring. Notice that there are two different method signatures for substring. You can either have just a beginning index, and you'll get from that position to the end of the string, or you can define a range. I'll use the first version. I'll pass in 11, and then I'll output the result. There are other methods that can be useful for manipulating a string in some way. I'll create a variable with the value welcome, with a whole bunch of space at the end. Next, I'll create a variable named len for length, and I'll get the value of s2.length. And I'll output that value. And I get back a value of 14. Now I'm going to call a method of the string class named trim. I'll create a new variable, I'll call it trimmed, and I'll call it s2.trim. This method removes any white space at the beginning or the ending of a string, where white space is line feeds, space characters, and tabs. Now, for manipulating a string in some way, I'll create a variable with the value welcome, with a whole bunch of space at the end. Next, I'll create a variable named len for length, and I'll get the value of s2.length. And I'll output that value. And I get back a value of 14. Now I'm going to call a method of the string class named trim. I'll create a new variable, I'll call it trimmed, and I'll call it s2.trim. This method removes any white space at the beginning or the end of the string, where white space is line feeds, space characters, and tabs. And I'll output the length of that trimmed string, and I get back a value of 8. As I mentioned previously, the string class has a wide variety of tools that are available for manipulating, inspecting, and other. Removes any white space at the. Create a new variable. I'll call it trimmed, and I'll call it s2.trim. This method removes any white space at the beginning or the ending of a string, where white space is line feeds, space characters, and tabs. And I'll output the length of that trimmed string, and I get back a value of 8. As I'll create a new variable, I'll call it trimmed, and I'll call it s2.trim. This method removes any white space at the beginning or the ending of a string, where white space is line feeds, space characters, and tabs. And I'll output the length of that trimmed string, and I get back a value of 8. As I've mentioned previously, the string class has a wide variety of tools that are available for manipulating, inspecting, and otherwise working with Java-based strings. In a command line application, you can get string-based input using a class named scanner. The first step is to create an instance of that class. In this beginning application, I'll create a variable that I'll name scanner, and I'll instantiate it with new scanner, and then I need to pass in a location from which the data is going to come. And I'll pass in the expression system.in. Now notice I'm getting a warning that this symbol scanner is recognized, so I'll place the cursor inside the class name, and then hold down the Alt or Option key and press Enter to return. And I'll choose the import class, and that will create the import statement that's required at the top of the file. Now I can receive input. Before I receive the input, I want to tell the user what I'm expecting. So I'm going time instead of print ln, I'll just use a method named print. And that'll output a string but keep the cursor on that same line. And I'll display a string of enter a value. Next, I'll get a value using this command, create a variable called input, and I'll call a method of the scanner object called next line. And that means wait until the user creates a line feed, and then return everything else that they've typed up until that point. Then I'll output the results, what the user typed in. And I'll run that code and test it. When I see enter, value in the console, I'll click into that area, and then I can enter any string and press enter or return, and I see that value repeated back to me. The scanner class also has methods that will convert the strings you enter into numbers of various types. I'll make a copy of this line of code that outputs a prompt. I'll paste it in a couple of times, and I'll change this one to enter number 1, and this one to enter number 2. After the first prompt, I'll create a variable called number 1, and I'll get its value from scanner.nextInt. Notice there's also next boolean, next byte, next float, and so on. And I'll duplicate that line and move it down, and this will be number 2. And now I'll add those values together. I'll create a sum variable and add number 1 and number 2. output the result, which the sum is, and then the value. And I'll run that code, and the first time I'm prompted, I'll enter any value, and that just gets echoed. Then I'll enter a number, and another number, and I see the two values are summed together. Now the scanner class will validate what you type in to a certain extent, but if the user types in something that doesn't match its expectations, it's just going to crash. I'll run the application one more time. Once again, enter any string at all, doesn't matter. Then watch what happens when I type something that isn't a number. I get an exception. And so the scanner class will work for very simple input. But if you want to do anything complex, we'll need to learn something about error handling, and I'll talk about that later in the course. In previous videos, I described how to collect user input, and then gave an example of collecting integer values and adding them together. In this challenge, I'd like you to do something similar. Collect user input, but this time get values that are cast as primitive doubles. These are numbers that have fractional values, and then divide one by the other. Now I'm hiding my code so you can't see it here, and I'll just run the application to show you what should happen. I prompt it for one value, and I'll enter any numeric value with a fraction. Then I'll enter another one, and the first number is divided by the second number. I'll run it again, and this time I'll set the first number as 24.2, and the second as 12.1, one half that value, and this time I get back an answer of 2. Try coding this yourself. Values and adding them together. In this challenge, in these videos, I described how to collect user input. In previous videos, I described how to collect user input, and then gave an example of collecting integer values and adding them together. In this challenge, I'd like you to do something similar. Collect user input, but this time get values that are cast as primitive doubles. These are numbers that have fractional values, and then divide one by the other. Now I'm hiding my code so you can't see it here, and I'll just run the application to show you what should happen. I prompt it for one value, and I'll enter any numeric value with a fraction. Then I'll enter another one, and the first number is divided by the second number. I'll run it again, and this time I'll set the first number as 24.2, and the second as 12.1, one half that value, and this time I get back an answer of 2. Try coding this yourself, then look at the solution next. One half that value. I'll run it again, and this time I'll set the first number as 24.2, and the second as 12.1, one half that value, and this time I get back an answer of 2. Try coding this yourself, then look at the solution in the next video, and see if our two solutions are the same. In the previous video, I used you the challenge. Create a very simple calculator application that can receive two values with fractions, and then divide one number by the other. I'll show you the code that I created to accomplish this. As in the previous video, I created an instance of the scanner class that system.in. This is something called an input stream, and it's data provided by the user in a console application. I use system.out.print without the print line to display prompts, and then after each prompt, I receive some data. Instead of using next line or next int as I did previously, I use the next double method, and that allows me to receive numeric value as a fraction. I receive two variables that I can use T1 and T2. You can name them anything you want, and then I divide one number by the next, and then I just await the result. Now remember, there are many ways to solve a programming problem, and your code may not look exactly the same as mine, but if it works for you, then you've solved the challenge. String interpolation is the process of evaluating a string literal containing one or more placeholders. In Java, you can do this with a method of the string class named format. In this code, I have 4 different variables, 3 strings and 1 numeric value. I've previously described how to convert a numeric value to a string using the primitive data types helper or wrapper classes. But you can also use a set of formatter classes to format numbers and currency values. You start by creating instances of these classes. I'll create one that I'll call numF, and I'll get that object using this expression, number format dot get number instance. There are a number of different methods that return instances of various objects. Now notice when I reference the number format class that there's an import statement that's being generated. Other classes have to be Writing conditional code is a common practice in all programming languages. The most common form of conditional logic is an if-then or an if-else statement. I've already used if statements previously in this course. They're pretty unavoidable. But now I'm going to the details of the if statement and how to put these people together. In this starting code, I've made a standard object as I've done previously, and I'm asking the user to enter a number between 1 and 12, and I'll evaluate the number that they enter. First, I'm going to declare a variable named message. It'll be a string, but I'm not assigning it a value yet. And that's because the if statement is going to result in setting that value depending on the number the user enters. An if statement starts with the keyword if. Then you put a Boolean expression that equates to true or false, into the parentheses. I'll do a little bit of error checking. First, I'll make sure that the month number the user enters isn't less than 1. Then I'll use the OR operator, and I'll check that it isn't greater than 12. If either of those conditions are true, then I don't have a valid month number. So I'll set the message to that isn't a valid month. Next, you can add as many else if clauses as you want to. These will only be evaluated if the first if statement is false. Once again, you put a Boolean expression inside a pair of parentheses, and if I have a month number that's less than or equal to 3, then I'll say that's equal to 1. Now I'll duplicate these 2 lines of code, and for this next version, I'll check whether the month number is less than or equal to 6, and if that's true, then I'll say that's equal to 2. And again, you can have as many of the else ifs as you need, but then at the end, optionally, you can have one else clause, and this code will take over if none of the other conditions were true. And here I'll set the message to that is in the first half of the year. finally, after the entire if clause is done, I'll output the message. This is a good time to talk a little bit about variable scope. The reason I declare the variable above the if clause is because when you declare a variable within a code block, it's only visible within that code block. When the code block is finished, the variable expires. So by declaring it here and then initially initializing it true. And here I'll set the message to that is in the first half of the year. And finally, after the entire if clause is done, I'll output the message. This is a good time to talk a little bit about variable scope. The reason I declare the variable above the if clause is because when you declare a variable within a code block, it's only visible within that code block. When the code block is finished, the variable expires. So by declaring it here and then initializing it in one of these sections, I'll know for sure that by the time I get to the end, I have a valid message. So now I'll run that code, and first I'll enter a value that is the valid month. And I get that message. Then I'll run it again and enter a value that does match one of the conditions, and I get the message I expect. Conditional logic can be based on information the user provides like this, or from a data store, or from information that you get from the system the application is running on. I'll comment out this code that's getting the month number from user input, and instead I'll get the current month from the system that's running the application. I'll create a variable that I'll name now, and I'll get it from the expression local datetime.now as a method call. Look, local datetime is a class that was added to Java it first made, and it's a member of the package java.time. It returns the current moment in time as the inherent value. And then from there, I can get the month number from the expression now.getMonthValue. The month number will be from 1 to 12. Notice that IntelliJ IDEA tells me that I have to get a value from 1 to 12 now, so my first if statement isn't going to be affected. So I'll turn my first else if into just an if statement, and I'll comment out this bit of code. I added comments by selecting some lines and then pressing Command/on Mac or Control/on Windows. And I'll fix the indentation. Now run the selecting some affected. So I'll turn my first else if into just an if statement, and I'll comment out this bit of code. I added comments by selecting some lines and then pressing Command/on Mac or Control. control slash on Windows. Then I'll fix the indentation, and I'll run the code again, and now I'm getting the month automatically. I'm running this code in the month of October, and so I get the feedback that isn't in the first half of the year. If you Now I'm getting the month automatically. I'm running this code in the month of October, and so I get the feedback that isn't in the first half of the year. If you're running it in a different month, you might see something different. So that's a look at how you can use simple if, else if, and else but. To evaluate conditions and execute conditional logic. The if and else keywords give you complete flexibility to write conditional code, but you can sometimes write that code more efficiently using the switch statement. A switch statement examines a single expression and then compares it to multiple possible values. You control the flow of execution based on when the values match. In my starting code, I'm getting the current month as a numeric value from the current system, and I'll add a switch keyword. When I select switch and let it autocomplete, IntelliJ IDEA adds a pair of parentheses. Add an expression inside parentheses. That you want to evaluate. This could be a primitive value, such as number, or it could be a string. I'll evaluate the current month number. Now, I'm going to press a keyboard shortcut that only works in IntelliJ IDEA. On Mac, it's Command-Shift-Return, and on Windows, it's Control-Shift-Enter, and that auto-completes the current clause. With the switch keyword, it adds a code block. Now, for each value I want to match, I add a case statement. First, I'll look at case 1. That would be for January. And if that value matches the month number, I'll say the month is January. At the end of each case statement, you typically add the break keyword. That means I'm done with this switch statement, jump to the end. I'll select these 3 lines of code, and I'll duplicate them a couple of times. This will be for case 2, and this one will be for case 3, and I'll change the month names. At the end of the switch statement, you can add the default case. And that's just keyword default. And I'll output, you chose another month. And then I'll run. This code. I'm running this code in the month of October, and so none of my cases match, and I get the default case. If you want to match that first expression to more than one possible value, you can do it with multiple cases without the break keyword. So I'll add a case 9, a case 10, and a case 11. Without the break statement, I keep on going through the cases. And now I can say it's the 4th quarter. And I'll get to that code for any of those 3 values. And once again, I'll add the break statement so I don't continue executing the default case. Out the break keyword. So I'll add a case 9, a case 10, and a case 11. Without the break statement, I keep on going through the cases. And now I can say it's the 4th quarter. And I'll get to that code for any of those 3 values. And once again, I'll add the break statement so I don't continue executing the default case. I'll run that code, and there's the result. I'm evaluating a primitive. Value here, the month number. But again, you can use strings as well. That was added in Java 7. So you can start with an expression in the switch statement that's a string, and then match it to other strings. The switch statement can make your conditional logic much more elegant than a bunch of ifs, if-elses, and elses. There are big changes coming for switch statements. Java 12 and 13 added the ability to make the switch clause as an expression that returns a Boolean value. And in version 13, there's a new yield keyword that offers even greater flexibility. But I'm not showing you those changes quite yet, because in Java 12 and 13, they're still in preview. So they don't even work unless you make a change to your project and how it uses the SDK. But you can find information about these changes at this webpage, all about how switch expressions will be designed to work in the future. Java provides a number of ways of moving through collections of data. I'm going to show how to iterate through a collection of data in a few different ways. In this starting application, I've created an array of strings, each value representing 1 month. Here. So here are 12 values, and I want to display each of them in the console. The first kind of loop I'll show is sometimes called an iterative loop. You can generate this code by typing 4i and pressing Enter, Return, or Tab, and that will expand to the template you need. This kind of loop uses 3 expressions, separated with semicolons. The first declares a variable, typically a numeric value, and when you loop into a collection of data, it's typically initially set to 0, and that's because Java uses zero-based indexing. The first item in the array is set via index 0, the second at index 1, and so on. The next is the condition. This is a Boolean value that says how long the loop will keep on running. In In this example, I want to keep running as long as the value of I is less than the size of the array, and I'll get that expression with months.length. Notice that in an array, the parentheses have no length. It's a property of the array, not a method. And finally, the third expression is a command, typically used to implement that value that was established at the beginning. And when you're moving through an array and want to get every item in the array, you'll typically increment by 1 each time through. Now, within the loop, I can execute as many commands as I want to. So I'll reference the array months and then put variable I inside the brackets. And I'll run that code. And the output shows 1 month per line. So that's how you can loop. Just about anything, and this is the oldest version of looping syntax in Java. But there are other, more elegant syntax styles that have been introduced more recently. One of them is called the for each loop. Now, I'm going to take this bit of code and duplicate it. Then I'll comment out the original version. And notice that IntelliJ IDEA is showing me a warning, saying that this for loop is replaceable with something called for each. I'm going to use a little quick fix trick. I'll hold down the Alt or Option key and press Enter or Return, and select Replace with for each. And my code changes. So now I have a variable that's being declared, followed by a colon, and then a reference to the array. This means loop through the array and execute this bit of code for each item in the array. Functionally, it'll be exactly the same as the original for loop, but I no longer have to keep track of the indices. I'll run the code, and you'll see that I get back exactly the same response. Starting with Java 10, you can replace the explicit declaration of the type with the keyword var. The compiler knows that that has to be a string because this is an array of strings, and that'll work too. There's a couple other kinds of loops worth knowing about. I'll comment this version out, and next I'll use a while loop. With a while loop, you still may need a counter of some kind, so I'm going to declare a variable that I'll name while counter, and I'll set it initially to a value of 0. Then I'll type the keyword while, and then I'll autocomplete that with Command Shift return on Mac or Control Shift Enter, and I'll set it use and that'll work too. There's a couple other kinds of loops worth knowing about. I'll comment this version out, and next I'll use a while loop. With a while loop, you still may need a counter of some kind, so I'm going to declare a variable that I'll name while counter, and I'll set it initially to a value of 0. Then I'll type the keyword while, and then I'll autocomplete that with Command Shift return on Mac or Control Shift Enter on Windows, and then I'll add a Boolean expression within the parentheses. Within the code block, I'll output month. Once again, I'll use months, bracket, and then the counter variable. And then I'm responsible for implementing the counter. So I'll say while counter plus plus. I'll run that code, and again, the result is exactly the same. And finally, I'll add a do counter plus plus. run that code, and again, the result is exactly the same. And finally, I'll add a do loop. This will be very similar to a while, so I'm just going to copy this bit of code. I'll comment out the while loop. Now I want to rename this variable while counter. Instead of trying to rename it every time it occurs, I'm going to use a tool in IntelliJ IDEA called refactoring. With the cursor in one of the instances of the variable, I'll press Shift F6, and that's exactly the same in all operating systems. I'll choose rename code occurrences, instances of the variable. Instead of trying to rename it every time it occurs, I'm going to use a tool in IntelliJ IDEA called refactoring. With the cursor in one of the instances of the variable, I'll press Shift F6, and that's exactly the same in all operating systems. Choose rename code occurrences, and I'll change while counter to do counter, and it's changed up. Automatically for me everywhere. Now I'll take this while statement and I'll cut it to the clipboard, and instead I'll put in a do loop, and then I'll paste the while statement right here. And I'll run that code, and again it looks exactly the same. So these are 4 different ways of looping through collections of information: an iterative loop, a for each loop, a while loop, and a do loop. They're all available to you, and it's up to you as the developer to decide which works best for your purposes. Most programming languages support either. parameters the method receives. The main method has a required signature in console applications. The name has to be main, all lowercase. It has to return void, which means nothing. And it has to be static, which means that it can be called from the main class without having to create an instance of the class. It also has to receive a parameter that's an array of strings, notated like this. The name of that parameter doesn't matter, it can be anything, but type is required. You can create your own methods and add them to any class. Methods can either be static or non-static. A static method is available to be called directly from the class itself. That is, you don't have to have an instance of the class. But if you take the static out, you must have an instance of the class. In a console application, when you create your own new methods, you'll typically make them static, so they're easy to call from the current context. Now, in it, required. You can create your own methods and add them to any class. Methods can either be static or non-static. A static method is available to be called directly from the class itself. That is, notated like this. The name of that parameter doesn't matter, it can be anything, but the type is required. You can create your own methods and add them to any class. Methods can either be static or non-static. A static method is available to be called directly from the class itself. That is, you don't have to have an instance of the class. But if you take the keyword static out, then you must have an instance of the class. In a console application, when you create your own new methods, you'll typically make them static, so they're easy to call from the current context. Now, in IntelliJ IDEA, I'm going to use a little tool that lets you take a little bit of redundant code and extract it as a custom method. This application has two versions of some code that displays a prompt and then gives a big input to the user. I'm going to select one of the versions of that code. Then I'll go to menu to the factor, extract, method. I'll name this method get input. Notice the signature preview down here is telling me that I'll be passing in a reference to my scanner object. I'll click refactor. IntelliJ IDEA looks at my code and says, hey, you have two versions of that code. Do you want to replace them all? And I'll say, yeah, replace. And now I have a new method named get input that returns a double value. It's marked as static, so it can be called from within this main method. I'll run the code, and the functionality. If I turn my code, it says, hey, it's telling me that I'll be extract method. I'll name this method get input. Notice the signature preview down here is telling me. That I'll be passing in a reference to my scanner object. I'll click refactor. IntelliJ IDEA looks at my code and says, hey, you have two versions of that code. Do you want to replace them all? And I'll say, yeah, replace. And now I have a new method named get input that returns a double value. It's marked as static, so it can be called from within this main method. I'll run the code, and the functionality of my calculator application is exactly the same as before. We'll enter two values and they'll be divided. by the other. Now I can make this method a little bit more flexible. Let's say, for example, that I want to have two different prompts for each time the method is called. I can add a new parameter here. This one will be a string, and I'll name it prompt. I'll select this prompt, that's just a literal string, and cut it to the clipboard, and replace it with that parameter. Now I'll go up to my first call to get input, and I'll pass that string in here, change it to numeric value 1, paste it in again here. I'll change this one to numeric value 2. And I'll run that code. And this time, I'm still calling the method twice, but I get two different prompts. And once again, the calculator works just like it did before. The purpose of custom methods is to allow you to reuse code. You can create as many custom methods as you need to, and you can design them, receive the data they need, and return the data that they calculate. class, we implement more than one method with the same name, but each of the methods must have a different signature. A method signature is determined by the method's name, and then the number and types of its parameters. In this starting application, I have two methods. The getInput method, which receives a scanner object and a string, and returns an integer value, and a method that I got named addValues, that receives two integer values and adds them together, and returns the result. I'll run the application and show that I can enter a value, and enter another one, and get back the sum. Now I want to add a new version of the addValues method. I'll select these lines of code and duplicate them, and I'll change this version so it receives 4 integer variables. And show that I can enter a value, and enter another one, and get back the sum. Now I want to add a new version of the addValues method. I'll select these lines of code and duplicate them, and I'll change this version so it receives 4 integer variables.
Aduh.
Name the third one I3, and so fourth one I4. Then I'll change the return statement to add all those values together. Notice that IntelliJ IDEA dims out the name of this method to indicate that it's not used yet. So I'll go back to my main method, and I'll duplicate these two lines, and I'll change this result variable to result of 4.
Mas itu ya.
Change the variable there too, and then I'll pass in I1 and I2 again. So now these two versions of the method are distinguished from each other by the number of parameters. The first version has 2 parameters, the second has compiler knows exactly which method to call. And when I run the application this time, and enter some values, I get back the result of the first call and of the second call. I'll go back here and change this output so I can clearly see where I'm getting the data from. And I'll run the code again, and there's the result. You can also create methods that receive variable numbers of parameters. I'll make another copy of this method, put it down here at the bottom, and this time, instead of having more than one argument, I'll just have one, and I'll name it value. And after the data type, I'll put in a dot, dot, dot. And that means I can receive any number of integer values. Now I'm going to change how I add the values together. I'll create a new variable that I'll call result. I'll set it to 0. Then I'll do a for each loop. I'll use the for each template, and I'll say that I'm creating a variable that I'll name value. I'll come back up here and change my parameter to values as a multiple. And then I'll say that's where I'm getting the data from. So now I'm looping through the list of values that are passed in. Within the loop, I'll incrementally add them. So receive any number argument. I'll make another copy of this method, put it down here at the bottom. And this time, instead of having more than one argument, I'll just have one, and I'll name it value. And after the data type, I'll put in a dot, dot, dot. And that means I can receive any number of integer values. Now I'm going to change how I add the values together. I'll create a new variable that I'll call result. I'll set it to 0. Then I'll do a for each loop. I'll use the for each template, and I'll say that I'm creating a variable that I'll name value. I'll come back up here and change my parameter to values as a multiple. And then I'll say that's where I'm getting the data. So now I'm moving through the list of values that are passed in. Within the loop, I'll incrementally add the value to the result plus the post value. And then at the end of the loop, I'll return the result. So now it doesn't matter how many integer values I pass in, I'll be adding them all together. I'll come back up here. I'll duplicate these two lines of code. I'll change the variable here to result of multiple. I'll change the output to. Then I'll copy and paste these arguments, so I'm passing in 6 values. its values, and this time I get all three sums. Again, the compiler is doing the magic. It looks at the number of values that are passed in and matches those up with the methods. Method signatures are distinguished from each other, again, by the number and types of the parameters in addition to the name of the method. You can have as many versions of each method as you need to satisfy the requirements of your application. In any programming language, you have to pass arguments to methods, whether they're being passed by copy or by reference. Let's define these terms. When you pass arguments by copy, you're passing an argument in and receiving a copy of that value. You're not referencing the original version. When you pass by reference, you're receiving a reference to the original object, and if you change anything within the method, you'll change the original. In Java, arguments are always passed by copy, but it may look like something else is happening, and I'll explain why. Let's start with the simplest case, primitive values. My method increment value receives a single argument, an integer value, a primitive. Within the method, it increments that value by 1 and outputs that value. Now, in the calling code, I establish an original variable, I output its value, I call the method, and then I output the original value again. In this example, the original value won't change. The value received within the method does not reference the original value, so you can change it all you want, that version will expire when the method is complete. Now take a look at what happens with objects. Complex objects, such as strings, arrays, and other sorts of instances of classes, frequently reference other kinds of values as members of objects. In this example, I'm receiving an object, an array. The array has more than one item in it, and within the method, I'm incrementing one of those items, the first item. Then I'm outputting that value. In the calling code, I'm creating an array with 3 items. I'm outputting that first value, calling the method, and outputting the original value again. In this example, I am modifying that original value. And you might think, well, how does that constitute passing something by copy if I'm still referencing something that existed outside the method? Here's what's going on. Remember that object variables are references. They aren't the actual values in memory. A reference variable points to a location in memory. When you pass a reference variable into a method as an argument, a new reference is created within the method. Both of those reference variables, one outside the method and one inside, can both be pointing to the original values. Here's a way to visualize it. I have an array containing 3 items. My original array outside the method is pointing to that first item in memory. When I pass that reference variable into the method, I get a copy of it, but that new copy is also referencing that original value in memory. So when I change it within the method, I'm also changing it outside the method. There's one object in memory, but multiple references. Now, the big exception to this is any kind of variable that contains immutable values. And you might think, well, how does that constitute passing something by copy if I'm still referencing something that... Now take a look at what happens when it does not reference. value. So you can change it all you want. That version will expire when the method is complete. Now take a look at what happens with objects. Complex objects such as strings, arrays, and other sorts of instances of classes frequently reference other kinds of values as members of the objects. In this example, I'm receiving an object, an array. The array has more than one item in it, and within the method, I'm incrementing one of those items, the first item. Then I'm outputting that value. In the calling code, I'm creating an array with 3 items. I'm outputting that first value, calling the method, and outputting the original value again. In this example, I am modifying that. Value. And you might think, well, how does that constitute passing something by copy if I'm still referencing something that existed outside the method? Here's what's going on. Remember that object variables are references. They aren't the actual values in memory. A reference variable points to a location in memory. When you pass a reference variable into a method as an argument, a new reference is created within the method. Both of those reference variables, one outside the method and one inside, can both be pointing to the original values. Here's a way to visualize it. I have an array containing 3 items. My original array outside the method is pointing to that first item in memory. When I pass that reference variable into the method, I get a copy of it, but that new copy is also referencing that original value in memory. So when I change it within the method, I'm also changing it outside the method. There's one object in memory, but multiple references. Now, the big exception to this is any kind of variables that contains immutable values. And the biggest example of this that you see all the time is the Java string class. Instances of strings are immutable. I mentioned earlier that when you modify the value of a string, you're really creating a copy because you can't change that reference. So if I have a method that receives a string-based parameter, I'm passing in a string argument, and then within the method I'm changing the value of that string, I'm actually creating a new string within the method. And that new string will expire at the end of the requirement convention when the method is complete. Outside the method, I create a string variable and I output its value. I call the method and pass the value in, and then I output the original value again. And here, as with primitive values, I won't have changed the original value, even though a string is a complex object and it references other values. So it's an exception to the rule. Strings are the most conspicuous example of this because we use strings all the time. But anytime you encounter a class where the documentation says the values referenced by this class are immutable, you'll see the same behavior. So again, when you pass an argument into a method in Java, you're always making a copy of the variable, but the values referenced by the 2 copies may be the same.
udah diblok semua ya. Ini yang atas nama Pak Herman barusan check in itu mau minta rumah terpisah, jadi rumahnya satu-satu, nggak mau satu rumah. Itu masih ada yang kosong nggak? Under 40 itu berarti 4 ya yang dipakai ya? Ya. Oh ya, oke. Berarti nggak apa-apa ya sendiri-sendiri ya? Ya, misal tipe 40 semua gimana? Tahu ya, dia tanya di tipe 40 apa? Dia kayaknya pesennya studio, standar studio. Tadi tanya dia. Nah. Oh ya, oke. Ini nggak dipesan gitu kan? Oke.
Continuing on with our tour of the Java programming language, I'd like to show you some tools that are available in IntelliJ IDEA for debugging your code. The first and most important tool to know about is called the breakpoint. A breakpoint is an instruction in your development environment that says, when I get to this line of code, suspend the application. While the application is suspended, you can inspect variables and see what their values are. In IntelliJ IDEA, you can add a breakpoint just by clicking in this area, known as the trough, right next to the line number, and you'll see this dot show up. Now, when I run the application and reach that line of code, the application will suspend. To make this happen, go to the toolbar and click on this little button that has an illustration of an inset. That means you're going to debug the main class. You can also get there by choosing Run, Debug, or you can go to the class and project window and choose Debug from here. I'll use the toolbar. In the console, I'm asked to enter two values as before, and now I hit my breakpoint. When you hit the breakpoint, a new window should open named Debug. The left pane shows you where you are in your code. I'm in the main method of the main class at line 12, and the variables pane shows all the variable values that are currently in scope. Args, which is this parameter, SC, which is a complex object, that's why there's this tree icon, and my two primitive values, key integers. Now I can step through the code using these buttons, and each of these has an associated keyboard shortcut, and I'm going to use the step over button. And each time I click, I'll execute a line of code, and I'll see the values change in the variables pane. I'll run that bit of code, that bit, and two more lines, and I now have all three results in memory. Then I'll click this button, which means step out, and that will take me out of the application. The process has completed. While a breakpoint is active, there are a number of ways to find out what variable values are or even complex expressions. I'll remove this breakpoint, I'll come down to my add values method that receives variable values, and I'll add my breakpoint here. I'll also add one here in the first one where I'm adding I1 and I2, and I'll run the application in debug mode again. Enter two values. And now, when I get to this line of code, I'll select this addition operation, I1 plus I2, which I select all of it, then I'll right-click and choose Evaluate Expression. The dialog that pops up, I'll click Evaluate, and there's the result. So now it's not my application doing the calculation, it's a process that's managed by IntelliJ. Close the dialog, and then over here I'll click this button, which lets me resume the program. And that'll get me to my final version of the method. And then once again, I'll step through, and I'll watch the value of the result in the variables pane. And I see how each time through the loop, I'm updating the result. So breakpoints and the ability to inspect values and complex expressions will let you see what your application is doing in the background. There are two broad categories of errors you can encounter in Java programming. First of all, there are syntax errors. These are code errors that you have to fix before you can even compile your application. Let's take a look at this simple comment. It starts with two slashes. If I were to forget to put in the second slash, I would have a syntax error. The Java compiler won't recognize that. It doesn't know what write your code here means. And when I try to run it, I'll get a compilation error shown here in the build window. I'll just get rid of that bit of code completely. I'm not interested in it. And instead, I'll show you a more common sort of problem. Let's say I'm trying to create a string, and I want to assign it initially to a value of null. If I don't put in my semicolon, that's a syntax error. And again, I can't even compile the application. Those are the most obvious kinds of errors that you'll see in your Java code. They're pretty easy to track down because you always get an error listing that shows you exactly where the error is and some sort of description of the mistake that's been made. Frequently, you'll be able to fix it very easily by placing the cursor using this error and then pressing Command-Shift-Return on Mac or Control-Shift-Return on Windows, and IntelliJ IDEA will do the best it can at fixing the code. The more complex problem, though, are exceptions. An exception is an error that occurs while the app is running. Let's take this string again. It's a null object. That means I don't have access to any of the object's members, properties, or methods. If I were to say, create a variable named sub, and I'll get that value from a substring starting at position 1, and then I try to run that code, I'm going to crash the application, and I'll get a special kind of exception called a null pointer exception. It's telling me I can't get to the substring method, which idea makes it very easy to add a try-catch block around a bit of code. Select the code that's causing the issue, then go to the menu and choose Code, Surround With, and choose Try-Catch. The code you select will end up in the try block, and a catch block will be added after. Here's how you can translate a try-catch block. I'll try to execute the code in the first block. If that code succeeds, the flow of execution will jump past the catch block, and I'll be down here. And I'll indicate that I'm down here by outputting a string of I'm not dead yet. If I run the code now, I'll see that I'm still getting the null pointer exception, but I'm handling it, and so the application can continue running. When you execute the catch block, you have a reference to an exception object. The type of the exception object is important. The type, by default, is simply exception. I'll click into that class and press Shift F1 and go to the documentation. Notice that the exception class has a whole bunch of different subclasses. Because the sub-object, two broad categories of errors you can encounter in Java programming. First of all, there are syntax errors. These are code errors that you have to fix before you can even compile the application. Let's take a look at this simple problem. It starts with 2 slashes. If I were to forget to put the second slash, I would have a syntax error. The Java compiler won't recognize that. It doesn't know what write your code here means. And when I try to run it, I'll get a compilation error shown here in the build window. I'll just get rid of that bit of code completely. I'm not interested in it. And instead, I'll show you a more common sort of problem. Let's say I'm trying to create a string, and I want to assign it initially to a value of null. If I don't put in my semicolon, that's a syntax error. And again, I can't even compile the application. Those are the most obvious kinds of errors that you'll see in your Java code. They're pretty easy to track down because you always get an error listing that shows you exactly where the error is and some sort of description of the mistake that's been made. Frequently, you'll be able to fix it very easily by placing the cursor where you see the squiggly error indicator and then pressing Command-Shift-Return on Mac or Control-Shift-Return on Windows, and IntelliJ IDEA will do the best it can at fixing the code. The more complex problem, though, are exceptions. An exception is error that occurs while the app is running. Let's take this string again. It's a null object. That means I don't have access to any of the object's members, properties, or methods. If I were to say, create a variable named sub, and I'll get that value from the substring starting at position 1, and then I try to run that code, I'm going to crash the application. And I'll get a special kind of exception called a null pointer exception. It's telling me I can't get to the substring method, which is supposed to be a member of the sub-object, because the sub-object doesn't exist. It's null. So how can you handle these kinds of exceptions? The answer is through a construct called try-catch. IntelliJ IDEA makes it very easy to add a try-catch block around your code. Select the code that's causing the issue, then go to the menu and choose Code, Surround With, and choose Try-Catch. The code you select will end up in the try block, and a catch block will be added after. Here's how you can translate a try-catch block. I'll try to execute the code in the first block. If that code succeeds, the flow of execution will jump past the catch block, and I'll be down here. And I'll indicate that I'm down here by outputting a string of I'm not dead yet. If I run the code now, I'll see that I'm still getting the null pointer exception, but I'm handling it, and so the application can continue running. When you execute the catch block, you have a reference to an exception object. The type of the exception object is important. Translate a try block around a bit of code. Select the code that's causing the issue, then go to the menu and choose Code, Surround With, and choose Try-Catch. The code you selected will end up in the try block, and a catch block will be added after it. Here's how you can translate a try-catch block. I'll try to execute the code in the first block. If that code succeeds, the flow of execution will jump past the catch block, and I'll be down here. And I'll indicate that I'm down here by outputting a string of I'm not dead yet. If I run the code now, I'll see that I'm still getting the null pointer exception, but I'm handling it, and so the application can continue running. When you execute the catch block, you have a reference to an exception object. The type of the exception object is important. The type, by default, is simply exception. I'll click into that class and press Shift F1 and go to the documentation. Notice that the exception class has a whole bunch of different subclasses. The exception class is at the top of an inheritance hierarchy. We'll talk about inheritance later, but what you need to know right now is that every one of these subclasses, these child exception classes, inherits everything that the exception class does. They have all the same methods, constructors, fields, and so on. And so that's why we're able to call this method print stack trace. That means tell me everything you know about the nature of this exception and dump that information into the console. So I run the code again, and all this output right here is being caused by the call to print stack trace. But because I caught the exception, the application can continue running. The try-catch construct is critical to handling exceptions in Java. You can add code that you know might cause a problem within a try block, and then you can catch and handle the exception in the catch block, and then you can let the application keep on doing its thing. When you start working with structured exception handling, you quickly discover that not all exceptions are equal. The exception class is the superclass for a whole bunch of different kinds of exceptions, and when you trigger an exception, you can find out very quickly what kind of exception you got. In this starting code, I'm going to encounter a null pointer exception. That's because I have an object that I've set as null, and then I'm trying to access one of its members that doesn't exist. And so when I run this code, I get this catch block, and I see the result of this print stack trace call. Because I handled the exception, this code survives, and I get to the last executable line. But you can use a structure called multi-catch, where you have distinct catch blocks for each different kind of exception. Let's say, for example, that in this catch block, you wanted to make it specific to null pointers. In addition to outputting the stack, I'll do an explicit bit of output that says null pointer, and then I'll append to that the message associated with the exception. And the expression for that is e.getMessage. I'll run the code, and I'll see that once again I successfully survived the exception and run all of the code to the end. Now I'm going to change the nature of the exception. Instead of setting the string to null, I'll set it to an empty string. Now when I call the substring method, I'll get an index out of bounds exception. I'll run that code, and I'll see my stack trace, but now I don't survive to the end of the code. I don't get to this last line. I don't have code to catch that particular kind of exception. So I'll add that here. I'll add a new catch block, and this will be specifically for string index out of bounds exception. As before, I'll create the variable with the name of e. Take this bit of code and copy it, paste it here. I'll change this label to out of bounds. And now when I run the code, I get my out of bounds exception, and I also get to the end of the code, because now I'm handling both kinds of exceptions. If you want to absolutely guarantee that you handle all exceptions, you can add another catch block and go back to handling exception here. I'll paste that code in again, and I'll change this label to I don't know what happened. When I run the code, I get the string index exception, and because I handled it, I survived in the end. This final catch block is only there to handle any exceptions I didn't anticipate. So that's a multi-catch architecture. You can have as many catch blocks as you need for the different kinds of exceptions you might need to handle. There are certain kinds of objects that you want to work with in try-catch blocks that need special handling. These are objects that you open for some purpose and then have to close to make sure you're not leaking memory. For most Java developers, the first time you encounter this is when you start working with files. In this beginning application, I've added a text file to the project's root directory. It's named hello.txt, and it contains just a single line of text. I want to read that file into memory. I've created an instance of the Java file class that references that file, and I have a bit of code here that indicates whether I can find the file successfully. When I run the starting code, I get a message saying that the file exists. So far, so good. Now to read the file application close to make sure you're not leaking memory. For most Java developers, the first time you encounter this is when you start working with files. In this beginning application, I've added a text file to the project's root directory. It's named hello.txt, and it contains just a single line of text. I want to read that file into memory. I've added a text file to the project. Project's root directory. It's named hello.txt, and it contains just a single line of text. I want to read that file into memory. I've created an instance of the Java file class that references that file, and I have a bit of code here that indicates whether I can find the file successfully. When I run the starting code, I get a message saying that the file exists. So far, so good. Now to
Gitu antum. Itu jadi peletakan batu pertama.
Belum
Peletakan
dong,
belum.
Belum.
Katanya hari ini.
nggak jadi.
Aku sampai pulang dari Jakarta.
Tahu gitu nggak pulang dulu,
Enggak pulang dulu.
soalnya enak.
Bener.
Maksudnya cuacanya. Kalau di sini kan dingin, di sana kan hangat. Bener. Duh, saya lupa semua.
Gitu tuh.
Kok wifi-nya konyol?
Konyol.
Iya nggak ada?
Kok konyol sih?
Enggak.
Enggak. Oh iya lumayan.
Ini gue aja nggak terkirim.
Contents of the file, I'll create two objects. The first is called a file reader. I'll name it reader, and I'll initialize this new file reader, and I'll pass in the file object. Next, I'll create something called a buffer reader. I'll name this BR, and I'll initialize it once again with a simple constructor call, and I'll pass in the reader object. Now I want to read the text from the file. I'll create a variable called text, and I'll get it by calling br.readLine. And finally, I'll output that text into the clipboard. Now, I have a couple of different exception indicators here. The first one tells me that I might encounter something called file not found, and the second one says you might get IO exception. I'm going to handle all that by wrapping all this code within a try catch block. I'll select all 4 lines, I'll go to code, surround with different exception indicators here. The first one tells me that I might encounter something called file. Output that text into the clipboard. Now, I have a couple of different exception indicators here. The first one tells me that I might encounter something called file not found, and the second one says you might get IO exception. I'm going to handle all that by wrapping all this code within a try catch block. I'll select all 4 lines, I'll go to code, surround with, try catch, and now I'm successfully handling the exceptions. file not found is a subclass of bioexception. So by handling bioexception, I'm handling both those potential problems. I'll run the code, and it works just fine. But here's the problem. I haven't taken care of the task that I'm responsible for. The file reader and the buffer reader objects must be closed. If you don't close them, you could have a memory leak. If you do it a bunch of times, your application could run out of memory. So to handle that, you could add a special clause called finding down here, and the code within a finding block gets executed last after everything else, no matter what else happens inside catch block. But then you have to do a whole bunch of convoluted changes. You have to make sure the readers are visible within all the code blocks. You might have nested exceptions, and so on. So instead, there's actually a better way. A try with resources block lets you declare these closable objects so that they're automatically closed when you're done with them. I'll go to the line that has the try keyword, and I'll add a pair of parentheses.
Serius
Now I'll select these two
amat.
declarations, cut them to the clipboard, and paste them into the parentheses. I don't need the closing semicolon here, and now the code looks almost exactly the same.
Serius amat.
Last time I used these objects within the parentheses, now they'll be closed automatically. I'll run the code again, and it functionally does it.
Assalamualaikum antum.
Waalaikumsalam.
It's the same thing, but I'm now secure in knowing that I'm not going to leave memory. Here's how you know whether an object has to be closed in this way. If you go to the documentation for the object, and then look at the implemented interfaces, if you see that the object implements an interface named closable, that means you are responsible for closing it. And that's a good indicator that you want to add the instantiation of that object into a try with resources section. In a previous challenge, I built a simple calculator. Select user again, without again. In a previous challenge, I built a simple calculator that let the user add a couple of values together. It didn't have any exception handling, and so if you entered a value that couldn't be parsed as a number, the application would crash. Also, it only supported one operation, addition. In this challenge, I'll ask you to build a more robust calculator, one that handles exceptions if the user doesn't enter a correct value, and then can execute multiple operations. I'm writing code for the finished version, and I'll show you how it behaves. I can enter two values, and then I'm asked to select one of four operations. I'll choose a forward slash for division, and I get back a value of 3.0. If I run the application again, and I enter a value that can't be parsed as a number, I simply get the message with the format as a number. Now, to handle this exception, you'll need to find out what kind of exception object it's going to handle. You can look at the documentation for that, or you can learn about it through experimentation. Enter an incorrect value and then look in the debugging code to see what kind of exception you get. Create your own solution to this challenge, and then in the next video, I'll show you how I solved it. In the a value that couldn't be part of this number, the application would crash. Also, it only supported one operation, addition. In this challenge, I'll ask you to build a more robust calculator, one that handles exceptions if the user doesn't enter a correct value, and then can execute multiple operations. I'm writing code for the finished version, and I'll show you how it behaves. I can enter two values, and then I'm asked to select one of four operations. I'll choose a /or division, and I get back a value of 3.0.